Yeah. And so it will be the presenter. Right now it's not. Oh, why is it? Let's mute this because we do not want an echo. There we are. But yeah, so there'll be controls up here to kind of steer it. I might make it presenter now.
Okay, great.
Is this me? This one's me.
Yeah, this is my first one of these.
Presenter.
So.
Yeah, sorry. The big blue button's a little bit weird. But so all the slides will be up there. We'll transfer it up.
Okay.
The big thing is like time-wise, I'm going to have
Yeah.
a little laptop. I'm going to be lagging you down at the various minutes.
Yeah.
And when it's time's up, it's you got to step off because we've got everybody
sure.
else lined up. So
Yeah, so I timed it out 10 minutes
sweet.
for the
That'll be
main
great.
content
Have
and
5
then
minutes of
questions.
discussion. Yeah, that's perfect. So
Okay, cool.
All right.
Chris.
Don't worry about it.
I don't have memory responses. But you don't think what it is. Yes, you can help you with the layout.
Yes. No. Okay.
Oh, sorry. Okay.
You understand.
At night, I missed my dog. At night, I didn't miss one time. It's okay, I know everything. So,
We have a bunch of cutting edge stuff.
I did.
Is Basil newer or is the previous option?
Somebody's like, right? I bet your brain. I bet your brain. That's not the point of this today.
You don't want to say that.
With the comfort zone. Yeah.
keys, when keys got here, he was just, he was the first thought, I was like, I'm just gonna go out, and use the money, or
Signing back and forth. No. Okay. Oh, well, I'll try. I'll try to just keep track.
You know what the hell is that? We did the poll. Yeah, what is he gonna do in here, man? Did you just say it out loud?
It's cheap. From like this. Okay, so it's either. It's central cover. It used to be. Because my job. I studied a maths club. I would probably talk. Yeah, exactly. Yeah.
No, okay.
One, two, sorry. Okay. No, I'm going to be talking for like 5 minutes and it's off to the next person. Yep.
Yes. Oh, yeah. There was one color. Bingo. Yeah, I have a really second. We could breathe.
All right. 1, 2. We're good? Right. So welcome to the Android Micro Conference, the 2023 edition. So, sir, could you get the door on your way in? That'd be great. Thank you so much. All right. Excellent. So, my name is Kareem Yagmor, and on behalf of the organization committee, John, Sumit, and Amit, who's not here, I'd like to welcome you all. I'm going to make this fairly quick. Just want to make sure all the ground rules are covered and everybody knows how this operates. Although we see a couple of familiar faces, so I'm assuming people are more or less familiar with the actual way we proceed here with these Android micro conferences. So this is the 11th edition, I guess, of the Android MC. It's been going on for a while. And it's been interesting to see the evolution of the relationship between the Android development team and the Android ecosystem in general with the Linux community. In the beginning, as some of you may know, was a bit of a free-for-all. There was a couple of mishaps along the way, but eventually I think we sort of started getting some stuff in place. So with, for example, the adoption of LTS requirements around treble, that was a good start. Then GKI, which took a couple of years to sort of stabilize, but I think is now in a pretty good shape. And now this in the rear view mirror, there's a couple of things definitely coming up in the future that will sort of be interesting to watch, like some legal requirements in some jurisdictions about maintaining software for a long time, which we hope will finally entice silicon vendors to make work upstream. If not the gentle way, well, the legislative way. But anyway, it's all for good laughs. But anyway, we're all sort of, welcoming any sort of upstream contributions, I think. There are also interesting topics within the lineup that we have today, which are going to be interesting to watch. Like, for example, the 16K pages, which are going to have some good ramifications in terms of the user space in Android. As well as RISC-V. So we went from, say, a couple of architectures down to almost exclusively ARM, though not the other guys are not left. And now we're sort of expanding back again, as John sort of puts it. I think that's a good way to look at it. So that's going to be interesting to watch as well. All right. And I don't want to take too much of your time, but let me just sort of walk you through the sort of modus operandi that we have here. So going to the next slide. There we go. Okay, so this is the hybrid format. You've got people online. You've got people here. Please speak to the mic or speak to a mic if you're asking a question. If you're receiving a question, please repeat the question so that making sure everybody sort of has heard that. There is a single laptop. It's all over here, okay? So your slides should be uploaded here, and we're going to just switch to the next set of slides at around 12, 14-minute mark, okay? You have 15-minute slots. For those of you who've been here before, you know how this works. We're fairly sort of stringent on that 15 minutes. Ideally, you're doing 5 minutes of talking and then taking questions afterwards. If you continue talking far north of the fifth minute without sort of stopping to even take questions, you will see me hand wave. And sort of around the 10-minute thing, I might just come up the podium here and make it more sort of obvious, all right? The break is actually it's not 15 minutes. I'm sorry, it's a 25-minute break. I think it's at 4:05, and we have a BOF scheduled on Wednesday morning. Some more talks there and a more open discussion because we've got a lot of actual talks packed for today. All right. Be aware there's a code of conduct, so read that up. All right, I'll let you do your homework. And of course, we thank our sponsors and so on and so forth. And with that, I think did I miss something, John? We're all good? All right, cool. So if the next person that's presenting here wants to, oh, there you go.
All right. So, hello everyone. I'm John Moon. I'm a software engineer with Qualcomm, and I'm going to talk to you today about the driver development kit and how we integrated it into our workflow. So I'll just tap here. Yeah, I think I got it. Here's the agenda. We don't have a lot of time, so I'm just going to get into it. So first, at a high level, I'm going to describe what the DDK is. So Google has this multi-year effort to move the entire Android build system to use Bazel, and they're starting with targeting the kernel build stuff. So that's the kernel itself and any external modules. The part of Cleaf is the framework that they developed to build the kernel stuff with Bazel. And one part of Cleaf is called the Driver Development Kit, or DDK. And as of Android 14, it's strongly recommended. So before DDK, I'm going to kind of give you guys an idea of what we were doing to build our external modules. For some background, we have a kernel team. That's the team I'm on. We manage our kernel platform tree and any common build definitions, ABI compliance stuff, that sort of thing. And then we also have tech teams, and these teams are split out into different Git repos and have a different place in the vendor tree. And they're specifically focused in a particular tech area, so display or WLAN, something like that. And we have about 50 modules that we build out of tree from these tech packs. So before Bazel came along, we were building with build.sh, as most of you likely were. And tech pack source code would live outside of the kernel platform tree, and they would have their module source code. They would have a kbuild file and a make file. And then we would have an android.mk file in that tech pack repo, and that's kind of how we linked it to the top level Android build. And you can see in this snippet here, we call out to this shared makefile build external kernel module.mk. And yeah, so all tech packs call out to this .mk file. And then in turn, that .mk file goes and calls out to build module.sh. That's a script we use that eventually calls this make command that many of you may be familiar with, that goes and builds a module out of tree. So the output KO comes and jumps back up the stack to the Android build system. So with DDK, build.sh is gone now. That's been replaced with Cleaf Bazel build commands. So to build our kernel module and to build our in-tree vendor modules, we have a Bazel build command instead of build.sh. And all that's defined in our Bazel files in repo. Tech packs, instead of having their kbuild and make file, now have a DDK module definition. So they have a build.bazel file as well. And here's an example of what a DDK definition might look like. So you can see at the top, they're loading the DDK module rule from Cleaf. And that's kind of like a Python import statement. And you define your inputs, your outputs, any dependencies you have, and the kernel you want to build against. And notably, kbuild and makefile are gone. Since the top level Android build is not using Bazel yet, we're still using android.mk, and we're still calling out to build external kernel module.mk. But now, when we go down that chain to our build script, we're invoking a Bazel build command to build the DDK target instead of that raw make command. One note about this method is right now, Cleaf assumes that all of your sources are underneath the kernel platform tree. So we make this symlink back to the vendor tree to kind of trick Cleaf into thinking that it's under kernel platform. This has to do with how the Bazel workspaces work. So now, after our experience moving everything over to DDK, I'm going to go over some pros and cons. So the biggest pro we've seen from the kernel side is the ability to limit kernel header visibility. So when a DDK module is built, all of the public kernel headers and all of its sources are dropped into a sandbox. And if a module is trying to use a private kernel header, such as mmslab here, it's going to say, hey, I can't find that file. It wasn't copied into the sandbox, so it's not visible. This revealed a bunch of places in various modules where we were using the private headers that we should not have been, and we were able to fix most of the issues. Another big pro is having some upstream support. So Matthias and Yifan have been great at helping us mold Cleaf to our use case and get all the features that our various tech packs needed into DDK. Another big pro is having less boilerplate. So in some cases with DDK, we were able to drop about half the lines of code that we have to express our builds. And that's largely because we can kind of vectorize and loop with the Starlark macros. So there are ways to do kind of elegant things to reduce your build definition logic. Another big pro, you can query your graph. So you can ask these kinds of questions of your build system and say, hey, which modules depend on me? And it can go answer that kind of question for you. It can be handy in unraveling a big thatch work. Another pro, you can pass an extra flag to your Bazel build command. It'll generate an output file, which you can then load into Chrome and see this kind of performance profiling graph. This is a great way to identify if there are any specific log jams in how your build is working, any dependencies that shouldn't really be there, see if things can be parallelized maybe. And then another big one is the interdependencies. So it was very common with our previous build system where tech packs would want to depend on symbols from each other or headers from each other. And there wasn't a very clean way of doing it. It was kind of tedious having to pass the makefile includes and concatenate your module.symvers. So DDK simplifies all of that. If you are a module that wants to provide something to other modules, you can list the public headers, and these are headers that are in your build directory that you would like to be exposed to other modules. And then you can also use native Bazel visibility to define which modules are allowed to depend on you. And then if you want to depend on a module, you just have to add the other module to your list of deps. It's pretty much that easy. You run your build command, it'll copy the public headers from that dependent module, and it'll also handle all the modules.symvers stuff for you. So that's all been radically simplified. The biggest con we saw during our transition was simply needing to learn a new build system. A lot of kernel developers are not familiar with Bazel or Starlark, so that was kind of a shock trying to integrate that. There was also a lot of confusion around the build phases of Bazel. So things would pop up with errors and say, oh, I'm not even building that part of the build. Why is that coming? And so there's confusion about the analysis phase and so on. And then another thing was seemingly simple things turned out to be very difficult. So Bazel forbids you from doing things like polluting your build with environment variables. So things that kernel developers have been doing for years and years no longer worked with the new model. So there was some pushback there, some frustration, but it's kind of a tax for ensuring the hermeticity of the build. So it is there for good reason, but it did break some existing workflows. And then last comment I'm going to mention is the debugging. So the sandbox I was mentioning earlier does complicate some things with debugging. So by default, after the build is complete, it'll clean up the sandbox. So if there were any breadcrumbs there that would help you to debug your build issue, those disappear unless you pass a special flag. And then there are also just long sandbox paths in your debug messages that tend to confuse people. So I think I'll quit there now. Stop for questions. I have some backup if we need, but yeah, any questions? Yeah, so I didn't get into it here, but pretty recently DDK did add the ability to have defconfig snippets in like the tech pack repo and the external module repo. And you can still go depend on those, and you can set that as your config or concatenate them with your own config. So you can still kind of cross-reference those just with the Bazel label to that file. And maybe Matthias can talk to that more. But
Understanding that the kconfig, like the .config that's generated, is only based on the kernel build document that you define or need to define. And so if you had kconfig, new kconfigs defined in your external modules, those wouldn't be.
yeah, but
So I'm just basically wondering if Qualcomm is running into this issue.
Yeah, so in general, you're right. The .config does come from the kernel build that you put into the DDK module, but then you can kind of have a supplemental, I guess, feature flags for your module. So that was pretty common for our tech packs. They would have feature flags that they wanted to define for various platforms. So nowadays in our vendor tree, we would have the tech packs would have a different def config per platform based on what features are available for that platform. And then I think those are just concatenated onto the .config. Sorry, I can't hear you. The .configs? Oh, yeah, so the question was, are they still implemented as header files? I don't believe so. I think under the hood, DDK generates an actual .config, and then autoconf.h is generated to resolve those.
I've seen a lot of external modules add in the make file like -d config _.
Yeah.
And it's hard coding the config, but that doesn't, it's not really scalable when you want to build the same external module source with other products.
Mm-hmm.
And we have a solution for this with Pixel, but I was curious if
Yeah, as far as I know, what we're doing today is the def config snippets in the various like per platform. John Stoltz.
I'm just kind of curious how you're finding using this process.
Yeah, so we do have some non-Android targets where we have been using Cleef, and it has been working well. Basically, it's a similar situation we were talking about where you kind of have conflicting build systems, right? The Android build system eventually works down to that android.mk file. A different build system like Yocto would do a similar thing, and you'd have a bitbake that would go and invoke the Bazel build command and produce the .ko. It would be much more elegant if everything was Bazel, obviously. We have some dependencies that are defined in 2 places now. So we're hoping once the whole Android system shifts that way, then yeah, it'd be easier.
Here's another small follow-on is as Qualcomm's been upstreaming code.
Mm-hmm.
I know in the past there's been occasional situations where what gets upstreamed and then what's in the product can slightly vary, and that sometimes can cause some collisions and friction. And I was just curious if you had been running into that as well with this new model.
We haven't seen this issue with DDK yet. I think we're just now starting to upstream stuff with DDK. So yeah, I guess I'm not sure.
Okay.
I also haven't been with Qualcomm that long, so I'm not sure about the history there.
You mentioned a con was that all your developers had to learn this new Cleef build system. Were there any resources that were particularly helpful trying to get that rolled out?
Yeah, so I would say the majority of the tech teams mostly just copied and pasted a template that we had. There were a few tech teams that were very interested and actually did learn the system, and others would kind of copy their work. But for the ones that actually did learn it, I found some talk on YouTube from a BazelCon, I think, that was kind of like a one-day introduction to Bazel, and that was helpful to get the semantics of everything. So I would recommend that. Got about a minute left. Okay, lovely. Thank you.
Just go to the next, right? I can do that? Okay. Yeah. Hi, I'm Matthias. I'm working also on the DDK for the Android systems team in London. I might as well steal your 1 minute. So the debuggability issue, like these long parts and everything, confusing error messages is actively something we are working on with the Bazel team. It's surprisingly non-trivial to get this at the same time the interactive output of Bazel, and on the other hand side, like a consistent stripping of irrelevant information. It's surprisingly hard, but we're working on it to make this actually better. It's also something that is frequently brought up as well. Okay, so this is kind of the continuation of John's talk. Basically, what he just showed you, this is just an enriched version with a little bit more code. Okay. Yeah. Did you hear me in the beginning at all? I'm sorry. Okay. So this is just a sample module, which is not using any particularly interesting features, but you see dependencies, you see symbol exports, using them, and how modules can depend on each other with the DDK. So that's all not new. What, like, as a recap, when you're using this, you're inheriting all the hermetic toolchain from the base build, compilers, linkers, everything. The whole boilerplate for like the whole makefile and everything is generated because we are still using kbuild under the hood. But the whole dependency resolution, orchestration goes to Bazel. So the question is like, what is new? And so that's what we're working on in 15. So things might change a bit, but the general idea is we want to make it as simple as, you have an empty directory, and in 5 minutes you get a flashable kernel module built against, let's say, a Google-signed GKI kernel image. In practice, might not look exactly like that because it's just not practical. That's not how you probably want to do it because of corporate boundaries or like how you acquire or like your download speed doesn't allow for that kind of 5 minutes pre-built download. But the general idea is we build against pre-built signed images. They might be in a CI system. They might be on your disk. They might be hosted in your corporate network or wherever it is. And you refer to them as there they are. And everything else comes, like batteries included. It comes with all the compiler tool chain and all the goodies that you get, except you don't build the kernel. Actually, you just build the module and you just focus on the modules. And you refer to them just as a repository. We are using, again, Bazel features to make this work under the hood, that you actually just have to specify a single line. This slide is not working. Yeah. So for example, you could specify a cleave repository on the left side, just like for example, build number that we use in crandroid.com. It could be a build number that you use in your own CI system. It could be a pre-build that is resolved by using, for example, our release branches. So we have like this particular case is not actually a branch, but a release tag, like Android 15.6.1, 2024, the January build, release number 1. You would just like point at it, and the whole magic under the hood would download the right tool chain, and you could build your modules against. You could also have like moving targets, like slowly moving release branches or development branches, or even have Android mainline as a moving target where you build against, without actually changing your particular vendor specific build files or your code. Except across major kernel versions, it's more than likely that your code might break, because it's just like, that's not a guarantee that the kernel gives, that the API is compatible. But upgrading within the LTS could just be like changing a string. It could be from Android 14.6.1 to Android 15.6.1. could just be a single string you change or you make configurable, and suddenly you have, like a module that builds against the one kernel or the other. Or it could be Android 15.6.1 to Android 15.6.6, which is kind of an LTS upgrade within Android 15, or to the next release branch, whatever is working for your workflow. Like you don't need to change your build files. You don't see any of these times build file changes except for where you get your pre-build from. And we are thinking about how to, because sometimes things break, so we need to depend on some things. It's just like really, really hacky. We could probably have defines provide or something that make transitions easier between major kernel versions or between Android 15 and 14 where features are available. But the main idea here remains that upgrades between kernels, between LTS, or even upgrading from the latest LTS to mainline should be as simple as upgrading the reference that you're using for. And as you can see on the bottom left, this is basically an upref. You're upgrading your driver from 6.1 to 6.6, and technically get 1 year longer support from LTS for that driver. And that's what we're actually doing it for. We want people to upgrade and eventually also to upstream. So what happens under the hood is not like you're caging in and saying, okay, you're locked in with DDK forever. No, the makefiles that are generated under the hood, you can literally take, and they're as upstream friendly as we can get them, including license headers and commons and dependency specification in a way that is friendly for upstreaming. So upgrading might not need actually changing a string. It might be just like making the module disappearing because it's already upstream. So like on the one hand side, yes, we want people to use DDK. On the other hand side, a world without DDK would be a very nice upstream way of resolving the same problem. Yeah, does anybody have any questions?
I'm curious about times when does it have a copy of it? Does it update that?
So the way this works under the hood is like, let's put the sources to the second step, but it resolves automatically. The way that this works, it basically creates shadow copies of each of those versions. For example, if Android 15.6.1 and Android 15.6.6 share a common compiler, they are stored at the local cache at the same space. But if you refer to them, if you actually build, the cleave repository rule creates kind of a shadow tree that looks like your current checkout, but out of all these pre-builds, and like it's manufactured together. And similarly, you can opt in to actually build from sources. And similarly, it would create the same trees as shadow copies and also make them available. We don't have to necessarily exactly panned out how editing this particular, like how you would map it into the source tree, because the idea this very pure idea of having nothing in your source tree than the DDK module itself kind of collides with having sources in the tree. But obviously this will need to be available as well. But we don't have necessarily the interface figured out how to swap sources in or how to make them available, especially in the presence of multi-branch system. So that's kind of work in progress, but we are going towards that. It should be easy to switch, but it should remain simple to debug, obviously, and to work on your own sources. And obviously to upstream, because you can move it into that tree, right, when you upstream. So we had an alternative interface that it's not off the table, but it's something that wasn't too popular when we asked around. It's basically to specify what is defined here as a variable, as an array of having multiple options at the same time. For example, 14.6.1 and 15.6.1 and mainline at the same time. And once your build kicks off, you build against all three at the same time. You download all the pre-builds, you know, everything at the same time. But again, you would only build against pre-built kernel binaries, having the three source trees available and in the source tree for you to see is still different from having pre-built something tucked away in your cache directory, and you will never look at it. So it's something we need to solve and eventually will solve, but this is good feedback. Yeah. I know what you're saying, but eventually you will upstream against exactly one version where you can take them all off. And in the latest version, you should be able to take them all off, right? Just like the latest that you upstream gets mainline should be without any if-defs. And don't nail me down on the exact syntax. That's really work in progress. And just to illustrate what kind of things we can do. It might probably look a bit more elegant than this. Okay, any further questions?
So for the, I'm wondering how you would generate a tag like this. I'm thinking of it as a chicken and the egg. So if I'm trying to build the de facto Android 15.6.1 repository, how do you go that path instead of the pre-built path?
You mean sources versus pre-builds? It will be a conditional. Like under the hood, we will have a basal select basal conditional, and how it's exactly configured via a flag, via a config, whether like you literally specify it in the sources. We're not yet sure, but for sure something like where you can dynamically switch, like -- build against sources. Should be it's fairly easy to implement. Yeah.
Okay, and it would produce some kind of output archive that then this thing can download.
Say again?
It would then produce some output archive that this tool could download as a pre-built. I guess I'm not sure what that looks like.
So the pre-builds that we produce on ciento.com are basically just the output of the basal build, right? So anything that you can produce with the Cleave build today will be suitable as a DDK. As for now, to make this kind of demo or this kind of POC work, what you see here on the slides, they have a patch, like a stack of 15 patches or something in AOSP that transform a pre-build into a suitable pre-build for this case. And once this all lands, literally every kernel build output, like distribution, is suitable to be taken into account as DDK. So there's not particularly DDK dist or something, or at least we don't plan to. It's just part of the normal kernel distribution. Where it packs up all the things that you need. Yeah.
Makes sense.
Or at least can refer to it, if like metadata referring to something else to download somewhere else.
Yeah.
It will be at least complete. Okay. Any literally last minute question? Okay, thanks a lot.
All right. I want other people to use it.
Hello, I'm Neil Capron. I'm part of the Android kernel integrity team, and I'm here to talk about access control for BPF programs and enabling core in Android. How do I advance the slides? Oh, perfect. All right, so starting off with some goals, we need to modernize the BPF frameworks in Android itself. So enable core and enable the modern libbpf based helpers. More information on that in a few minutes. The other primary goal is enabling secure vendor access to BPF trace points. This is something that we've been asked for a long time and haven't been able to open up just yet, and ultimately build a solid foundation for future use cases. So some of the requirements we have, we really need to minimize impact of boot time. We've actually had to revert some of the BPF functionality in the past due to low performance devices really getting delayed up to like seconds on boot. We need to be very cognizant of our use of memory in this, and we need to control access to where BPF programs are attached. So for those of you who don't know much about BPF, this is a very simplified high-level overview. Essentially, it's a system to extend kernel functionality from user space in a secure manner. It's a virtual machine in the kernel that can basically, a program is compiled to BPF bytecode, and then there's a BPF application which includes functionality to load that bytecode through a syscall into the kernel. On the kernel side, there's a verifier that makes sure that there's no indefinite loops, that reads are initialized prior to being read, things like that. And ultimately, these programs can be attached to the events, various event sources in the kernel. So trace points, perf events, things like that. There's BPF maps, which allow you to have communication with user space as well. So libbpf is the primary user space library used with BPF. It's maintained as part of the kernel tree. There are other libraries being developed at this point, but this is kind of the reference implementation. It provides helper functions for a lot of the application development, things like that loading piece, attaching to the trace points, map creation, and has the core implementation. So this is a very important piece to enable. So I've mentioned core. What is it? It's compile once, run everywhere. So basically, it attempts to solve portability issues for BPF programs which are compiled into bytecode for one kernel version and then running on another kernel version that may have resized structures or moved things around. It's important to note that it's a user space concept, and it does not address the use case where the meaning of a structure variable changes. So Android's current implementation, we have a single point of access for BPF loading. So that is BPF loader. It runs as part of the early init process, and it's a single threaded program that loads all of the different BPF programs from various sources. It's based on a custom library, and I say library very generously, a series of header files that handle the syscalls, things like that. And it is very out of date compared to modern standards. So here's a block diagram of that. You can see the three different program classes or sources on the left side. So the system is part of AOSP. Networking is in an Apex. So this is things that monitor like bandwidth and do attribution to applications for that. And vendor. So vendors basically can layer their programs on top of it. However, they're very restricted currently. So then for the BPF application, it loads a file and it compares that file based on where its location is to an allow list. And we'll see more on that in a second. You can see the Android specific library there. And yeah, next slide. So these are the program types. It's a small subset of what's available upstream. You can see networking is by far the largest user of this. System has a few more permissions, and vendor has only socket filter access right now, but has requested tracepoint, performance, or perf events and kprobes. So how do we go about enabling core in Android? Well, we could continue to do our custom Android specific library. I don't want to do that. That sounds like a maintenance nightmare, and we'll always be lagging. We can integrate the standard libbpf into the existing BPF loader. This still has some challenges about it. Specifically the boot time and compatibility. This is a major one, is because we're dealing with the kernel version, the vendor program version, and the system library version, and the BPF loader's inclusion of this. There's all these pieces that could change independently, and is a compatibility nightmare. So the third thing I've come up with is basically enabling programs to use libbpf natively, and I have block diagrams for this in a few slides. And the big thing about this is it resolves the compatibility issue, but there's work that we need to do to develop an access control mechanism. And there are probably other approaches, so I'm open to feedback there. So attach point access control. So in order to open up this access, we need to control what functions and where you can attach things in the kernel. So the programs need to be, or the trace points need to be part of the KMI before we allow attaching it. So again, this could be accomplished by extending the BPF loader with an additional allow list, or we could create a BPF program or kernel module that hooks into the kernel's BPF program load or BPF program attach functions, allowing us to validate at a lower level. So this is the first approach of extending BPF loader. So you can see the big changes here is we've moved networking off to its own net BPF load application. This is due to the networking apex running on devices that are about, that go back to 4.9 kernels that don't have modern core support. And the primary BPF loader has an additional attach point allow list in there, as well as the libbpf library with the core relocation mechanism. This is kind of the proposed native libbpf solution that I've come up with. So basically each application at whether it's system, vendor, or networking can all use whatever library to perform the syscall they want. And it can be statically linked, resolving the compatibility issue there. And if you look in the bottom right corner, you see the new functionality for the access control BPF program. So kind of hooking the syscall as part of loading it, as well as attaching it. So with this, we need to be able to update this from user space. So that's a piece I have yet to figure out. That's one of the big questions is how do we do that? And I have some questions lined up here that I can come back to, but ultimately, what do the vendors need from us? Are there other approaches that we can consider, we should consider? Is security going to allow this new approach? Because they are a lot of the definition they were the reason for the current definition of the policy and how come it was so restricted. And looking forward, what other program types can we enable, should we enable, and how to control that. So with that, I'll open it up to questions. I know I covered a lot of material very quickly, but yeah.
Hi. So one of the first question I have is like BPF, you can do the same basically with kernel modules really, and you already have vendor hooks and all the kind of stuff. So what's the use case we are enabling over here? One issue that worries me with BPF is that I feel the auditability or being able to audit it and security as well. And I'm not sure if it is still completely, you can enforce open sourcing the code of BPF or not is something that concerns. And I'm not sure what you can achieve with BPF that's not already achievable by writing a module that hooks into the hooks the same thing. Sure. Because it's doing the same thing really.
I think one of the main reasons for BPF is the security that it provides going through that verifier piece. It really does, it has a cleanup. So memory leaks, it validates that the memory that you're accessing is there and initialized. So there's a lot of security and pieces there. Obviously, it is opening up the interface to a lot, and that's where we need to be cognizant about where we attach things. And other than that, we want to allow people to continue this development, right, and see where it can go.
All right, so when you ran through that the first time around, it sort of made me think about SE Linux. I was just wondering, why not just extend SE Linux to sort of have some sort of cognizance of what you're trying to do here, and that would sort of be useful to other people as well?
Yeah, I honestly have not considered that approach. Some of the upstream approaches have looked at what's called BPF tokens, where you validate the source of a program and delegate a token to do certain actions. The concerns there are timelines of including a greater development piece like this. I feel like a BPF program could be implemented in the short term. And then as the community continues to grow the security pieces around it, we can integrate them going forward. But really to enable vendors short term, this is something that could be attainable there.
I snuck out of the BPF track to come in. So
Yeah.
thank you for this presentation. I just wanted to sort of try to cross-pollinate a little bit. I know there's been some discussions about what we call like a gatekeeper program.
Yep.
In that space around perhaps having a policy based on BPF, even to enforce who can load BPF. So there are programs like Tetragon out there that I think can do this sort of thing.
Yes.
And then there's a lot of related discussions around signing of BPF programs and stuff like that, which also sort of relates. So I just wanted to bring that up in general, but yeah.
I appreciate that.
I don't know how
am
much time
speaking in a couple
Awesome.
a couple hours over there, cool. And I want to address those concerns directly because I think what's out there right now is very targeted towards cloud applications and more about who can load stuff in the kernel. We need a lot more granularity as to what can people do when they're using a program in the kernel or when they're attaching it. So I want to extend that conversation there. So.
And maybe a question. So I think you had kind of two models. Maybe one is a program type allow list in user space, and the other is maybe enforcing it in the kernel.
Yep.
What's your base? Do you have a
So the current approach with the BPF, this application here in user space, it doesn't solve the boot time problem. And as more BPF users show up or more people are using BPF, I think it's really just going to continue to delay that boot process, and limit what libraries can be used along with the compatibility of the vendors programs are compiled against this version, systems compiled against this, and networking's here. And so really trying to solve it at a more generic, lower layer, and then allowing user space developers to really do what they want.
Yeah, so I was actually wondering about that user space compatibility thing as well. So I guess if your BPF program is referencing kernel structures and you upgrade your kernel underneath without upgrading user space, there could be breaks there, correct?
Yes, absolutely. So basically, there's a lot of policy that we need to define as Android as a whole about who's responsible when certain things happen as far as kernel updates, because we don't have that KMI stability between kernel branches.
Yeah.
So there's a piece there that we need to develop on the policy side things. And I think right now we're basically looking at when the kernel is upgraded, all bets are off for the existing pieces. But we're trying to understand the user space compatibility so that people can move forward there.
Yeah, it seems like from the upgrade scenario, you would want to consider them almost like external modules, right? And upgrade them alongside your kernel.
Yeah.
Okay.
As far as like user space, and kernel compatibility goes, currently, like we support launching new devices with like the latest Android version on multiple kernel versions. You can launch Android 13.5.10 with an Android 14 or Android 15 user space. Is that going to pose a problem as far as like jumping to the latest libbpf library?
Yes, absolutely. So that's where we're trying to trying to figure out the ability to separate that. The existing stuff right now is very much tied to the network apex, and so that's being separated out, and we're kind of looking for 15 forward. And as far as how GRF plays into all this, I am working that out still. So that's open for discussion, and I really need help with the team to help define these things. So, thank you very much.
Yeah, well, I mean,
Yeah, how do I go slide like next? Here?
Yeah, we have
I guess. Cool. Right. Hello, everybody. I am Carlos. I work for the Android kernel team at Google. Thank you for joining. I'm going to talk about binder driver and a very specific issue, a performance issue that we had, and how did we solve it. Before we get into this performance issue, though, just a bit of background. So this is the model, the general model of how binder is used in Android. You just have this bunch of clients that are trying to talk in parallel to the server. It's a client server model. And what happens on the service side is that there's a thread pool, and you have all these threads that are trying to service all these individual transactions in parallel. You know, the unique thing about binder here is that the service is going to memory map a region of memory, and all the different clients are going to try to compete right here for a region, for a piece, for a range of that memory map. And you know, that's where the performance impact that we're going to discuss happens. Even though you have all these threads, you still need to compete for a section of memory right there. By the way, you compete because binder performs a copy from user memory A, client 1, for instance, directly to the service memory map area. There's no in-buffer. There's no in-kernel buffering. So if we have a close-up at this memory region, the section, it is a single virtual memory area. And the way that binder works is that it partitions. It's not particularly page aligned, but what it does is that it has this concept of binder buffers, and each binder buffer is like metadata of the range of the VMA being assigned to that particular transaction. Each message or each transaction gets an individual binder buffer. And you know, but this is all virtual addresses, right? We still need to make sure before we start copying, we need to make sure that physical pages are associated with a particular address. So, you know, in the case where we don't have a page associated, then what binder does is that it manually allocates and inserts that page for that particular address. And on the release path, right? Once the server consumes the message and it says, okay, I no longer need it. I've read whatever I needed to read. So let's just release the binder buffer. We go ahead and sort of clear that range. But what's important here is that we don't actually free the page. We just add it to this least recently used list that it's global within binder. And when there's memory pressure and the shrinker is trying to reclaim a particular page, then that's when we actually go ahead and free the page, give it to somebody else, and you know, rinse and repeat. Okay, so there lies the problem, right? All these requests need to be serialized, and we do so via this mutex, this per process, per server mutex, which, you know, just was receiving a ton of contention, particularly during the graphics core pipeline. And so, you know, what was the issue? What was happening, and why was that particular scenario a problem? So a low priority task would take this mutex, and it was typically, say, a background task running on this like super saturated little CPUs, and it would then go to sleep with the mutex held. And all these high priority tasks that are trying to use that server would just get blocked. And because it was, it was not spinning on the owner, they would also go to sleep, and then you have a big problematic scenario. So what made the situation particularly an issue, or particularly a bad issue, was that we nest the memory map log under this mutex. Now, why is that? The whole pipeline of assigning a particular mutex may or may not require allocating and inserting a new page. And when you do that, to be able to insert the page, you need to acquire this memory map. It's a semaphore. And if somebody else was holding that map log on some unrelated VMA, then it would go to sleep and increase the chances of creating contention. This was particularly an issue when we were trying to reclaim pages at the same time. So you had this loop of you trying to allocate a page, you don't have memory for it, and then you acquire the log, try to reclaim a page, you get it from a different binder process, and you return, and it was just a nightmare with these logs. Sorry? So
Sorry, which lock are you trying to acquire in that scenario?
The memory map log on the server. And so the top log is this alloc mutex, which controls this whole procedure. And under it, if you don't find the page, that's when you do acquire the memory map semaphore. Only then.
Okay.
That's changed.
Yeah. Okay.
So what is the solution, right? What is changing now? First of all, we remove all the operations that might sleep. Some of them were pretty trivial, like pre-allocating stuff. You can do that outside of the mutex. That's easy. But then the major change, I guess, is to split the process of setting up the range of the binder buffer separated from the actual page insertion. And the idea there is that if you can do the two things separately with like different logs, then they're now no longer nested, number one. And two, if a particular request doesn't actually need to insert new pages because it already has pre-allocated all of its pages, then it can just go through. It doesn't matter if some other request needs to allocate a page. They're not serialized in that case, which is great. So at the end of the day, it turns out that all the operations that would sleep or that would require having a sleeping log under the alloc mutex, they were gone, right? We were not longer doing the page insertions under the mutex. Mallocs and all of that, were gone. So we were able to turn the mutex into a spin lock. That was, significant performance. There's a V1 that I posted. And so what are the results? It turns out that during the worst case scenario, we can get even like 200% improvements, which is great. It was amazing. This is not a real case workload. It's particularly a stress test meant to like showcase this particular new way of processing things. And this is well timed, by the way. This is like transaction well timed, seen by the client. And this particular test just has a bunch of different clients, different priorities, sending, particularly transactions of different sizes as to wanted to create fragmentation instead of like reusing old ranges. And but anyway, the V1, it's there. There's still some things to, I think, wrap up. But overall, this would create significant improvements under these particular scenarios. I think that's it. Questions?
Do you have any sense of how much contention there is under mmap block after the changes?
Yeah, so this used to be pretty bad before, like the per VMA locking.
Yeah.
That was particularly worse.
Okay.
And also, there's another way to make changes. Right now in the patch set that I have, I'm actually synchronizing, because two different clients can try to raise to allocate and insert the same page. I'm synchronizing them with the write mode log, and that's not ideal. I think we want to have maybe like a per page mutex.
Yeah.
A per binder page mutex, not a struct page mutex. And then underneath it, use not the framework, the framework page, but a binder page mutex that would resolve this serialization and use a memory map read log instead, because you can actually insert pages with or you should be able to insert pages with only the read log. So what I'm saying is that binders should only use the memory map log as read mode at the end of the day. And if it needs to be synchronized during those particular operations, then it needs to be done via some other way. Perhaps it's not actually a mutex, but a fault in, trying to fault it in with a retry mechanism. What is this flag? VM fault retry, something like that?
May fault retry, yeah. So one of the things that, I don't know, on the service side, well, you mentioned that the binder buffers aren't page aligned. But if they were, then you could have multiple VMAs, and then you'd only have contention within a thread, and you'd never see that.
Yeah, so most of this is because of the size of each transaction. Most of the sizes,
Really
most
small.
of the messages in binder are way less than the page size. It's under 1K. So yeah.
Cool.
Did you consider any lockless synchronization methods?
Yeah, like I said, there's some work, there's some room for improvement there for sure. There are some data structures, like instead of using a red-black tree, we could move over to the maple tree, which you can do some operations under the RCU. And I think it provides also like cache-friendly efficiency, which is great. There is still some improvements to do. Also, this API of faulting in pages could be done without, so that multiple clients can try to fault in a specific page can be done without synchronization, sort of like a retry. All of this is supported by the infrastructure. So binder doesn't actually need to do this like retry mechanism. So yeah, there is some room to do some lockless implementations in there for sure. Last minute questions?
Was this issue replicated in the Rust implementation? And if so, was it mitigated in the same way?
We have not tried to replicate this, but we could and measure it, what happens. Yeah, that's a good idea.
So I'm the author of the Rust implementation.
Sorry?
I'm the author of the Rust
Yeah, no,
implementation.
yeah. The question was to both of you, actually. So,
Yeah.
was it seen?
So I haven't tried that benchmark that Carlos shared, but so the implementation that's in the RFC is much more similar to what's in the patch set that Carlos sent recently than what's actually upstream today.
Do you use mutexes in that?
Yeah, we use a spin lock.
Thank you.
Hi, I'm Betty from Android kernel quality team at Google. Today I will talk about kernel and platform integration testing that we have enabled at Android common kernel branches. Okay. So for all the still active kernels, we have enabled the kernel and the platform integration. Here, the slides shows a table that we have maintained. So the oldest kernel that we are still testing is Android 4.14 stable kernel that is integrated with Android 14, 13, and the Android 10 platform branches. And it spans all the way to the Android 15.6.1, the most recent kernel, and Android mainline kernels. So the Android kernel testing is a complex and a challenging task. So we want to catch the kernel breakage and regression as early as possible. So we push the kernel testing upstream to the Android mainline branches. It will allow us to detect regression as early as possible and also close to when they are the breakage are introduced. We also work actively with the upstream maintainers for quick resolutions. With the early regression detection and resolution, we want to ensure that no surprise at the upref phase and no late and accumulate headaches at the later phase. We partner with the Ninaro for mainline and LTS release candidate testing. So Android kernel testing is a multi-stage test process, and it starts as early as pre-submit. For every single change that was checked in the Android kernel, there's a pre-submit test. We not only have the build time checks and tests like API stability analysis and simple allow list testing that was enabled at built-in. We also have the runtime platform integration test like the boot test, CTS, BTS, and etc. So here we provide a screenshot of the code change what's checked in the Android 14.6.1, and in the checks tab you can find the pre-submit test result. Unfortunately, right now our external partners don't have access to this tab, and we are working with the Gary team to make it available to our external partners. So what test has enabled the pre-submit? We have enabled pre-submit test on the ARM64 kernel integrated with on the physical device like phone, watch, foldable, tablet. We also leverage the virtual device to increase the test coverage on ARM64 and x86 kernels. And the virtual device testing provide better debug and kernel log for triage failures. The kernels are tested with all compatible and updatable Android versions. The test including boot test, CTS, VTS that we have mentioned. And here is the screenshot of the test that right now that are only available to the Googlers and is not exposed to the external partners yet. We want to make it easy for Android developers add pre-submit tests at the kernel branch. So we have maintained a pre-submit test plan at Android platform branch with the test mapping kernel pre-submit test group. So in the AOSP main platform source code, you can find the kernel pre-submit test. For example, here there's a kernel proc file API test that was enabled in the AOSP main branches. And the test was added with the test mapping kernel pre-submit, and they can be run with the A-test at the platform source tree as well. So we provide some simple example of A-test command to run the kernel pre-submit test. The kernel pre-submit test plan is also enabled as a pre-submit at the Android platform branch. So which means that for any test updates or platform change, they will not break our kernel pre-submit testing. You can search for kernel pre-submit test in cs.android.com by the keyword kernel-pre-submit. And here is a snapshot of the existing kernel pre-submit, it including a bunch of CTS tests, VTS tests, and that are critical for the kernel. With the existing kernel pre-submit test plan, we have the 30% line coverage and 35% function coverage. Oh, by the way, we enabled the GCOV enabled kernel so that we can capture the kernel code coverage without the testing, pre-submit testing. So what's next in the pre-submit? We will start enabling the performance regression detector at the pre-submit. So there's a performance test at the pre-submit phase. And we will enable the K-union and K-self test from the kernel source code. We have K-self tests at the kernel pre-submit, but they are the test binary that was built from the Android platform branch. So they are not real time, and they're not test against the kernel code change and the K-self test update, for example, at the kernel branch. So with the new infrastructure that we introduce in the kernel tree, the developer will be able to run the K-union and K-self test in their local environment on Android devices, as well as in the Google Lab environment. We want to enable the target quick pre-submit with the kernel code coverage data we collected to increase the kernel coverage while minimize the test runtime. We are also looking to add new verticals like Android TV and Android Auto at the kernel pre-submit. Other than the pre-submit, we also have post-submit at all kernel builds. The post-submit test, including the app compatibility test. Right now we have top 100 app launch test, and we have enabled performance regression tests like boot performance, syscall latency benchmark, geek benchmark, app launch benchmark, DVFS benchmarks. And also we have extensive CTS and VTS enabled at post-submit phases. Challenges. So the kernel and the platform combination keeps growing along with all the Android device verticals that we want to support. So the test space keep growing. And it's very hard to triage kernel bugs on the Android devices. And we are hoping to have more tools. And recently we have enabled the kernel debug build targets and enabled with Android Cuttlefish, the virtual devices, to offer better logs for the triage. And it's very hard to bisect device boot failure or test failures, given the volume that we have receiving from the LTS updates. That's like hundreds of file changes every time, and it's very hard to bisect the test failures. Okay. Yeah, any questions? And yes, please.
At Red Hat, we have a similar issue. We support 4 different platforms: PowerPC, Z Series, and ARM. We started doing builds and discussing builds for the various combinations. What tools do you use to build your testing site? We use GitLab, Beakert, and we're looking at testing farm for a moment.
So we are using the TradeFat, the test harness that was maintained in the Android platform branch for the test integration for the kernel and platform. TradeFat, Trade Federation. It's a test harness that is available in the Android platform branch. And recently we have added the TradeFat as a prebuild in the Android kernel tree so that we can easily use the test harness offered there to launch cuttlefish, like run the test on Android devices. And the TradeFat is also used in the Google Lab automation.
So I'm not familiar a lot with your work, so I was just wondering how much of the results are publicly available and how much of the infrastructure is publicly available for others to sort of do the same thing that you're doing?
Okay, so for example, A-test, TradeFat, all those test harness, they are available. And in terms of the test result access, Google maintain ACL for those test results, but right now it's we are not making it easy accessible for our partners, and we are working towards that to make it available to partners. But overall, so for any code change that you submit, you can run the test with Google's lab infrastructure. And with the A-test and some extra guide that we provide, you can reproduce those test failures with your local device as well.
Kareem, yeah, just an addition. So for the tests that are run at Linaro that are open, you can still go and always check the results. There are quite a few that we do on dev boards.
Thank you.
Yeah, so I'm with Chrome OS and we have our own exploding number of combinations. So out of curiosity, you say the platform combinations keep growing. How many are there at the moment and how quickly are they growing?
So yeah, so here we have a matrix. Sorry. Yeah. So yeah, right now this is the combination that we maintaining at this moment. It's like more than 20 combinations, and for each combination, we are talking about multiple verticals and platforms. So yeah.
Yeah, I encourage you to come and have a look at the Chrome OS combination. Who's next?
All right, great, thank you.
Yes, pretty much. Always makes you feel better, right? Yeah. Thank you so much.
Oh, yeah.
You're struggling with that thing? What slides? These are the 2 hours. Go forward, backward.
Okay. Afterwards, will that keys work? Oh, okay. I'll just.
After I do that, will that work?
No, it seems that you don't. I've tried it. For whatever. So.
Waiting a few seconds more before. Okay.
It showed up for me, so I didn't see it.
Okay.
I'll get started. Good afternoon, everyone. Thanks for being here after lunch. It's a struggle. I'm here to talk about Suspend Resume for Android. It's basically a bunch of pain points I'm going to complain about and see what we can do about it. And also want to know about what people are interested in that I can try to focus either my effort or my team's effort on. So why do we care about Suspend Resume time? So the most common one is when you hit the power button on your phone, the time it takes to start drawing something on screen. That is a metric that users care about, and you don't want that to be slow. The other one is if you have a Wear watch and you look at it, the time it takes to turn on the screen and display the time, that's like really sensitive. Because if you look at it and you have to wait for like a little bit to see the time, that's not a good experience. And any useless work we do during Suspend Resume is not useful either. You're wasting power. And again, makes a lot of impact on a wearable device. And then if you're having the kernel non-Android, let's say, on a door camera, and it's going to wake up and start recording, the time to come out of Suspend and whatnot is going to affect the time it's going to take to record. I'm sure there are multiple other reasons for having better Suspend Resume. So these are the high-level issues that I'm aware of and things I'm looking at. One is there can be cyclic dependencies between devices, and firmware dev-link tries to parse the device tree nodes and set up the dependencies. But when it hits cycles, it struggles. I'll get to it more on the slides. We want to complain about S2 RAM versus S2 idle. And then is it do we need to do runtime PM versus do asynchronous Suspend Resume? Those are again things I want to get the feel for on what the vendors might want. So yeah, so before we can optimize Suspend Resume, we want to make sure it's stable and dependable. That's where the firmware dev-link part comes in. So as I was saying earlier, firmware dev-link can detect cycles between devices and device tree. So something that came in the past 2 months or so. The pin control depends on regulator depends on I2C, I2C depends on pin control. It's a 3-device loop. They all point to each other. There's no way to know which is the right order to probe them or suspend them. So firmware dev-link just throws up its hand and says, okay, you figure it out. I'll figure out the rest of the devices. So one of the proposals I want to do is, and then because of the cycles, now all the cycle breaking is done on a driver level. They'll have their own properties saying, if this consumer is trying to get this resource, don't defer probe, let them continue, stuff like that. And even the frameworks, they have to add and remove device links. So I think GPIO does it, maybe regulator does it too. And technically, we would be able to delete them if we could handle cycles correctly in firmware dev-link. And the long story short, there's not enough information today in device tree to figure out what's the right sequence if you have a cycle in DT. So I'm proposing adding something like post init supplier to indicate, hey, I don't need that supplier for my init. So don't block me from probing before that supplier. So Rob had kind of tangentially told me it's okay to add. He was supposed to come in. I think he's sick, so he might be on chat. But feel free to interrupt me on each of these slides. I want to kind of finish one and then move on. So do people have any thoughts on this, any opposition to this or not? And if Rob's saying anything on chat, that'll be kind of good to know. Rob Herring. Okay. So if there's no strong opposition to this is something I'm going to add. And then after that, if you have a cycle, the regulator can say, hey, I know I point to the pin control as a pin control requirement, but don't block me for that guy. So it's more as an exception list instead of additive list where say I need that supplier. We'll still figure that out using existing DT properties. So we can bike to the name maybe later on. But this is something I'm planning on sending out if there's no, that's a question from Kevin.
So once you implement this, isn't the next somebody's gonna ask for init 1, init 2, init 3, and we're gonna be back to the same like levels of dependencies, just like in init calls?
This is okay. When I say init, it's not like init call. I can figure out a different name, but basically what I'm saying is for the driver to be able to start initializing this device and making it available. Another shitty name that would be specific to Linux would be post probe supplier. That's what I'm trying to say. but I'm trying to not use the word probe.
No, but what I mean is the same thing with the init calls. Like it's post, right? But post what? You're gonna post one and then post two. And then...
No, so at least the way
it's a worry. I think this is a good idea, but I'm worried that we end up with
I don't see that
levels
necessarily
again.
happening because I don't plan on making it. Yeah, I don't think it'll do that. I'm struggling to explain why, but like maybe there's like a gap in understanding or thought process there. Oh. Yeah. Okay.
We don't have a Rob here. Does it work? Yep. But the problem with the property you mentioned there is that you now describe the dependencies of the Linux system inside the device tree. The device tree is supposed not
That's
to
why I didn't call
describe
it.
the-
That's why I call it post init. What you need to initialize the device. Nothing to do with Linux. You can use this for Windows too if you want.
Then from that point of view, we already have this property expressed because there is a regulators are already provided as a regulator supply, clocks are provided. So you have all this information about missing resources.
Okay. Let me clarify. This is like saying, even though I might say, hey, I need the regulator, I'm saying don't block me on the regulator. So I'm not trying to add a property to say what you need. I'm adding a property to say what you don't need, despite you in device tray saying you need that resource. But you would reuse the resource after you probe. Yeah, something like that. Don't need it yet if you want to call it, but don't need it for probing. So yeah, this is definitely not meant to replace them. That's explicitly doing it this way, where it's not used as a crutch to point to things you need instead of using standard properties. So this doesn't replace them.
Yeah, you're suggesting a device tree property here. Would it also make sense to say declare this in the driver because the driver knows what it needs at probe time, which might be
But every driver is
different.
doing their own implementation of it, and every driver is trying to do their own implementation of breaking the cycle. Just like saying we have standard clock properties, I'm saying standard dependency cycle breaking properties. What I'm looking for here.
Right, but like, would it make sense for the driver to say, I don't need whatever I point to in the clock property to probe?
So
Whereas normally,
part of the thing that firmware dev-link and device links try to do is also try to prevent unnecessary probe attempts and incorrect deferred probes. So the drivers don't even get to run yet for them to tell me.
right, and instead of like a different error thing, like not eProbe defer, but something like declarative in the driver that says, here are the device tree properties that I need at probe time, or here are the ones I don't need at probe. That way it's not, you're not polluting the device tree with something that's Linux specific, but the thing that is Linux specific is the driver implementation itself.
Yeah. So number one, again, I don't think the property is Linux specific, but also firmware dev-link tries to stay away from getting the information from the driver as much as we can, because that kind of brings back some of the problems it solves already. We start depending on the driver. Then again, when does that driver get to run? Would they running in the right order to tell me that they don't need it? It kind of gets complicated. Okay, in the interest of time, I'll go to the next slide. Yeah. Oh yeah, so one other thing I want to do to try to improve Suspend Resume in general is try to move as many devices as possible to runtime PM, at least for Android, if not for everybody. And there's a firmware dev link equal to RPM option that basically sets the runtime PM flag on all the device links. So basically it'll make sure during a runtime resume suspend, your supplier requirements are taken care of in the right order. So if you depend on a regulator and then you're coming out of runtime suspend, it'll wake up the regulator so that everything's done in the right order. I'm going to enable this. I've never used this flag and I'm not a runtime PM expert. So I'm just trying to see if there's any bad things would happen if I do this. So I know Rafael is here. If anybody have thoughts on it or Ulf. No? Okay. Yeah, okay. Yeah, okay. Then I'll try it out and see if I'll send it out, we'll merge it. If it breaks, we can continue fixing it. Hopefully that's okay. Man, this mouse is annoying. Okay. The next part is also right. So the whole point of this is to if you're trying to draw out the first frame for the lock screen when you hit the power button, I don't need to wait for USB to resume before I missed the questions. Okay, cool. Yeah, so if everything's runtime PM, does global async matter? I guess that's one of the questions I'm trying to figure out. Do people still see the need for it? Are they thinking, hey, I'm not be able to get runtime PM working on everything, so let's try to get this working too. And then when I looked into this, I heard from some vendors doing global async actually is worse than selectively doing async, and that doesn't sound good to me. Ideally, the kernel should just take care of it by default. Yeah, Mike, please.
Okay, so a comment on this.
Can you? It's really low, the volume.
Yep.
Yeah.
Works?
Uh-huh.
Works. Okay. A comment on this. Absolutely make it async.
Huh?
Make it async.
Sorry, no, make it easy. Yeah.
Async. Yeah.
Okay.
No synchronous. There's no need for synchronous suspend resume except for legacy stuff, and I mean legacy.
Okay.
If you have any new driver which requires this, Okay. You can.
So just before I came here, like when I was preparing the slide, somebody came and said, "Oh, but if I try to global async, there's a flag I believe to do global async for everything."
Yeah, there is, but there is stuff that will break.
Okay.
When you set it, but then there is no reason for leaving it like that.
Yeah. So I think breaking was like functional correctness. We can make sure it's correct, but I think it's actually taking longer than selectively doing async.
There may be cases where things like depend on the sequence, and they take logs in the wrong order, things like that, and then block on them, and then wait for.
Is thread forking a concern I should be worried about? Where I'm like, if it takes say microseconds to resume, should we run all of them in like one serial, one thread, or should we still?
So I don't have specific examples, but it is possible in principle. But anyway, because there is this legacy I was talking about, right? Otherwise, it shouldn't be necessary, and everybody should do async or async suspend resume, and I mean really. And if you
do runtime VM, do you still see a need for async suspend resume? Technically, it shouldn't matter, right? Or am I missing anything there? Okay.
No more comments.
Okay, cool. The last one slide, we tried to do S2 idle instead of S2 RAM. For people who are not aware, S2 RAM is suspend to RAM that hot plugs out all the CPUs except the last one before it suspends the system. And the S2 idle is where it lets CPUs go into low power power collapse, where the CPUs just go idle. You're not hot plugging them out. And after that, it does normal suspend path. So a couple of issues I ran into. One of them was Cisco ops are not called in S2 idle path, but drivers were still using it. So yes, we shouldn't use it. I remember Rafael said that in some mailing list, but we still see quite a few drivers using it. Is there a reason we should continue allowing Cisco ops, or should we make it a deprecated API kind of thing? That's one question.
Actually, I still had a question on the previous slide. That's why I wanted. Did the manufacturers ever substantiate their claims on why the global was slower? I mean, they can measure a lot of things.
I didn't
right?
have time to dig into it. Yeah, I don't have.
Yeah, because I mean, like CPU utilization, there could be other things that are slowing it down, right? Or scheduling or whatever.
Okay. Rafael or on him too, I guess.
So for the Samsung drivers, I'm pretty sure this is some legacy stuff that we didn't have runtime PM in the clock drivers. Therefore, we expected that there's some, Cisco. So this can be all.
I have only 1 minute left, and the last thing I want to complain about is a bunch of drivers doing stuff in the hot plug notifiers because they're saying CPU specific stuff, they're quieting their watchdog, for example, and then we don't send hot plug notifiers yet. So that's another missing piece. So I almost feel like the whole Cisco ops and the hot plug notifiers, we need to give like a simple way to transition, but maybe support both, just like how we do for suspend resume and runtime PM, right? If you implement one, it's used for the other. I almost feel like something like that might be making things easier. I got 1 more minute, Rafael.
Again? Okay, so absolutely, if you can make S2 idle work.
Make what?
Make S2 idle work.
Well, yeah, I know, but
this is the way to go. Honestly, no shortcuts. Make it work.
Okay, but Cisco and hot plug, you do see the issues, right? And I can write.
No hot plug. So S2 idle doesn't require those things. It's just
Okay.
that.
Well, I'll talk to you offline.
It doesn't require any kind of like stupid scrubs. This is only for this RAM.
No, that's the last line. Yeah.
I was going to say, we have CPU PM notifiers, so can you use that?
We tried some issues there, but
What were the problems?
time's up.
Okay, so we're going for a break at 4:30. We're starting over. All right. So I'll see you folks in 25 minutes.
Just this? Oh, you just have to do it with the, okay. Oh. Okay. It's, yeah, it's like focused on the other part of the window or something. Oh well. I can click on UI elements with the mouse. That's fine. Yeah, just so that it's considered a separate component. It starts to get a little less. Yeah, yeah. So we might pull that as one goes in the dragon. Yeah. We'll let me take it. That's the thing that we are yeah. People are really I mean, it's just more. It's like a mix of security.
Do you want to touch the wet hat?
Sorry?
Do you want to touch the still damp spots?
No.
Because you had to wipe it down. As the first guy who took it together this morning, it's the super spreader box. I know, I was like, dang, I'm really hard.
How you doing?
I heard that maybe tomorrow is 87.
Yes.
That's very exciting.
Yeah. I'm thinking you beer early.
I think it made sense for the first day. But, nice. I'm liking it. I hope that I like being in the being like on call and like having some like freedom elsewhere. But I would love to come back next year with like loads more experience. And be like, look at me, you know. So I was an assistant manager at Spirit this season. I'm hoping to get some like music theater internships. I'm the investment in retail makes decent money, but I'd love to work more in like arts and stuff and be able to maybe a gallery. I'm like interested. I got a photogrammetry and I got a photo degree at a sound minor, so I'm like interested in both parts, you know. Yeah, and then maybe I feel like I'm young and I'll and if I get a stage here like on call for 3 years, I'm sure I'll get to a point where I'll be ready for more. But this is like my own job. What I was telling Cruz, so it's like, you know, I want to explore and then become around 25 is what I heard. I think I still got two and a half more years. You gotta make it happen. So do you do other things outside of technical now?
I mean, I get hobbies and stuff, but mostly I do play my shoe where I'm really answering. Trying to rebalance it.
Have you seen those guitars that roll up?
I have seen that. I'm actually very interested in the
Have you heard of Eurorack simulators? Have you heard of Eurorack, the modular synthesizer?
Yes.
Have you heard of the RISC-V rack?
No.
So it's an open source program that's free that emulates Eurorack, and you can make your own modulars. I don't know. You can put you can put your electronic saxophone into that and make not saxophone.
Yeah, I do a lot with Ableton these days. And I just got the one synthesizer that was
What's into that? It's not a move, so I know.
In college, we had a mini move. Yeah, it's cool. It's 2080. I got one of those. I want one of the matrix groups.
No, I haven't. Oh man. That's
Yeah.
yeah. Alrighty, I figured it out. I figured it out. The tracker that's been on the charger is dead, basically. Which is why this is so nice to put together.
Got it.
Yeah, I'm like, I'm not going to put it together. Well, that's it.
All's well.
All's well.
Awesome. I just saw those two from the outside looking here. I'm like, I'm gonna go and make sure everything's cool, but you guys are already here.
Let me check on the colleague.
Figuring it out.
Another battery.
Okay. Seems like the coffee isn't doing enough.
I think the coffee wore out.
Yeah. It's worn out. That's what I said though. Yeah. I've been sipping continuously, so it doesn't. So the Zoom's getting on full. The whole thing. Not that we usually watch it all the time. It's not like it zooms in on people, you know, it's just like, if you can just point it to the very movement. Yay! Thank you very much. It is unlabeled. Thank you very much. Yeah. I just want to say hello to people.
So if you want to take back your seats, as they say, well, we're going to start over. Curtis, the floor is yours. Just a really quick intro here for flipping slides, because everybody's confused.
Clicking on that. Okay.
These 2 hours. All right.
Hey, everybody. I'm Curtis Galloway from Google, the low-level operating systems team. And so I'm here to give an update on Android and RISC-V and hopefully prompt some discussion. So if you've been in the RISC-V session this morning, some of this may sound familiar. I'll start with the status. It's pretty good. Android can build and run in an emulator now using the same mechanisms as other platforms. So I'm sorry, Betty, from earlier, we're adding to your matrix. We're working hard on getting all of the tests running, but they're not part of the mainstream CI yet. So vector crypto, bit manipulation extensions have landed. Vector is in progress, mostly because of the performance in QEMU is not what you want. NDK canaries are available also, and Cuttlefish is using QEMU 8.1 with vector available in there. So you can test vector. Performance obviously is not really useful to test in QEMU. And GFX stream support is added for better local graphics performance. And importantly, we're working to land stuff upstream first for the libraries that are in use. So it's I have someone on my team that is actively working on upstream vector and various things, for instance. So upstream is important. We're trying to get that straight from the get-go. I think the question we get the most is, what is up with the ABI? And the answer is probably not what you necessarily want to hear. It's a work in progress because the important decisions on extensions in the space are still happening. We don't want to converge on an ABI that is either has something that might get removed or doesn't have something crucial. So we want to make sure that there's consensus on that before being really adamant about what the ABI is going to be. But having said that, this will look familiar if you've seen Lars's presentation from earlier this year in July. So the supported ABI will be added for 64-bit, no 32-bit, sorry. And all supported instruction sets will be a combination of probably RVA22 plus some set of ratified extensions, probably vector crypto, since those are pretty important for performance. We're intentionally omitting SIMD and scalar crypto from that list of things that are required. And we'll also require that Android compatible devices are conforming hardware. So correctly implement the ISA, don't do anything broken or weird, don't misuse any of the encoding space for future extensions to do your thing. We want to promote compliance with fully compliant hardware. And we will only ever support ratified RISC-V extensions. So I think we can say that for now. And that has been a message that's been pretty consistent since earlier this year, at least. So the hard part is if you're trying to do stuff with vector in particular, it's hard to tell on emulators. So interesting boards now are starting to become available. I mentioned the K230 because Nathan is here and has one if you want to play with it. Oh, you got to give me your visual prop here. We have one in a nice 3D printed case. Yeah. Look, a box, a cardboard box. This is useful for testing libraries and doing work on that. It's not really useful for running Android, but I'm pretty hopeful that more boards are going to come really soon now, probably early next year maybe. And RISE in the RISC-V International Forum is working on a board farm. We already have the CI going if you want to use that, but a board farm will be a lot more useful. So we're working on a proposal for that to enable people to actually test things on real hardware, which will be a lot more interesting when there's more of it. And so if you want to figure out what's going on at any given moment, go to the GitHub page for Android RISC-V, try it out. You can download it and run it. You can look at the issues list. And there's a open source blog post that I linked to in here that has some more detail on the tooling and kind of what we're thinking on that. And for RISC-V generally, there's an Android SIG mailing list. That is where all the discussion happens. So all of this is happening in the open on the mailing list, on the GitHub issue list. So you can see everything that's happening and see all the code that's going in. And I would encourage people who are interested in RISC-V on Android to check out RISE and try to get involved with that, because that's more about enabling the RISC-V software ecosystem generally, which will help Android and everything else. The wiki on the RISE webpage has more info on the working groups that are going on there, including the board farm. So if you have boards and you want to farm them, please show up and get involved. And also help your favorite project do RISC-V optimization. Like we're working on all that stuff in upstream. So anything you do in there is going to help Android and everything else. Any questions so far? Anything that I've missed?
For vector crypto, are you referring to the NIST algorithms, the Chinese algorithms, or both? Like vector crypto is it's a family of extensions.
Right. Nathan, do we have the list of exactly which ones for vector crypto that which of the many vector crypto flavors are we actually using? I think just the NIST and I don't know offhand.
Yeah, hi. As Curtis said, we're targeting ratified extensions, so that would be vector crypto or vector 1.0. And you said vector crypto. Which of the extensions in vector crypto?
Right.
I don't have that offhand. I believe that we do have that list public somewhere, and I can get that to you.
Yeah.
But
I think it's in one of the issues on GitHub. I could be wrong.
I think if you go to github.com/Android RISC-V64 has a list of all the open issues, and in there includes the crypto stuff.
Yeah, if I don't want to say and be wrong, because what I remember may not be correct. Any other questions? Yeah, there's a bunch of kind of issues on there that are still open, like more ASLR bits, shadow stack support, which is partly landed, and crypto optimizations in the kernel, missing hardware breakpoint support, distinguishing read-write faults in user space. So there's a bunch of stuff that's being actively worked on. If people are interested, yeah.
Yeah, so maybe I missed it, but did you say you had some reference hardware you're aiming for, or some dev boards that we may be?
We have one.
Oh, yeah, that's the one you were mentioning. Okay.
Yeah, the goal is, so we're not doing any internal Android builds on particular hardware. Through Rise, we're interested in trying to get a board farm going, but just having some of these around, since you could just buy them now, that's kind of what we're using them for sitting on your desktop, and it's something that if we're trying to upstream vector improvement, at least we have something that you can say, well, try it on this, and here's the improvement we saw.
And let me just push my question a bit further down, because I know that some of the dev boards that are listed for Android are maintained by Linaro. Sort of in my mind, there's sort of like a disconnect there. But
oh well, we should totally talk. So this is
So who would be doing that?
which part?
The supporting some RISC-V boards, since I would sort of conclude that maybe Linaro would not be the party doing that. So who would be doing that for you?
Well, that would be Rise. That would decide what So the proposal that's sort of in draft form, that's one of the questions is what boards get to go in, and do they need to be completely RVA22? So Rise not equal to Android. It's just more that the K230 is the first easily available one that has vector 1.0 that you can just go order and get it in some reasonable time.
Gotcha.
Yeah.
Right.
5 more minutes. You all are really know how RISC-V on Android is going now, and think it's good. That's good. You should be tougher on me.
Anybody from the RISC-V crowd wants to address specific questions? Yeah.
We got one.
Might flip it around and say, what questions do you have for kind of the upstream community, or that would be helpful?
Yeah, what do you want to see Android do in the short term, right? Do people have, if people have opinions on what Android should support, or strong feelings on which of the vector crypto flavors are important to do, I think it's a good moment to chime in.
Is the kernel that you guys are using based off of ACK or pure upstream? And if it's based off of ACK, are there any Android specific patches that are maybe RISC-V specific
We're trying, it's ACK, and we're trying really, really, really hard to not have any. So the goal is to be, you know, completely mainline on things. The hard part is, you know, because the hardware is all landing imminently, there's going to be vendor stuff, I'm sure, but we really want to try to encourage everything to be upstream first. That's super important. Like, I'm personally relatively new to Android, and I hear a lot all the time about how important it is to like minimize the number of patches. So currently we're at 0 for generic RISC-V support.
Cool.
Yeah. No, I think we're doing it wrong.
This is Trilok. Just want to catch up on the string library kind of optimizations like memcopy or something. We had a long time back to do that in the ARM. So pretty much interested in what you're doing in optimizing these libraries for Bionic and I don't know, there was an extension for these two specific instructions, but are we looking into that, optimizing these paths?
We are, and Nathan, do you want to comment on that more specifically?
Yeah, so I can answer that question also. We have landed optimized versions of the string and memory routines using the vector extension. Those are currently landed. A lot of them are patterned after some of the recommendations, so they're already there. Most of the Bionic functions exist and are optimized, so those are already done.
Thank you, Nathan.
When you say that the implementation has to be conforming, is that from strictly a user space point of view, or are you, is that a requirement extend to say privilege mode as well?
I would say both. I mean, I don't know if you want to do something crazy in user space. Doesn't seem like, I don't know. Nathan, do we have an opinion on that? I'm sorry to keep throwing things back to you, but I don't want to make an incorrect position.
What was the question about?
For conforming, like hardware conforming to the spec, do we care more about kernel or user space? I mean,
I guess the only thing I can kind of add there is that Android will support. We'll have some ABI at some point that will be mostly for application conformance, and then if there are devices that have other conforming extensions, that are for platform, perhaps they could be used there, just like we have currently with ARM, where if there are other ARM operations that are just on the platform, maybe the platform could take advantage of it. But we are going to add a conformance test of some sort to the CDD, as Curtis said.
I mean, I think that's something, if like, oh, we have a great idea about that, then I would encourage you to have a conversation about like what you'd like to see on that. Because otherwise, I think it's to everyone's benefit to have things conform to the published standards so that we don't fragment the ecosystem. All right. Thanks, everybody.
Yeah, I guess. Thank you.
I think so.
So slides are changed by going back and forth with these arrows.
Hello, everyone. I'm Elliot. I'm presenting today with Prakriti. She'll come up here in a few minutes. We're going to talk today about adding a third-party hypervisor to the Android virtualization framework. So this is going to kind of be an overview of what AVF is, what Ganya is, and then what's going on just as a status update. So for those of you who don't know, Android virtualization framework is a fairly new framework. We're trying to add new protected virtualization use cases. So there's a lot of things in firmware, some use cases that Android apps want to sort of move out of sort of main Android into an isolated use case. And so Android has a new framework for that. David gave a great talk about that last year. Definitely encourage you to check that out. So Qualcomm's been using Gunya now for, how many years has it been? Do you know? 5 years? 4 years? 4 years. It's an EL2 hypervisor. It's a small microkernel. And we have a resource manager VM that sort of manages access to all the vCPUs and in-memory management for VMs. And so you have Android that goes to talk to either the hypervisor or the resource manager to do different virtualization stuff that you want to do. So some key design differences from other hypervisors. We designed it from the beginning to be for VM isolation. So we see a lot of other hypervisors are sort of adding that in later. We started from the beginning to have deprivileged VMs. You can read all these other different things. We had EL2 based scheduling as well. And one other important thing is Qualcomm has other business units besides just mobile and wearable. We also want to support our auto and IoT use cases. So that's one reason why we have our own hypervisor. So here's a pretty brief rundown of some hypervisor requirements for AVF. Some of these are going to be pretty basic. You need to be able to launch a virtual machine. It's pretty simple. One other thing that seems pretty simple for upstream community, but was a little bit different for us, you need to be able to handle MMIO access from vCPUs. Prakriti will talk a little bit more about that. Shutdown support. These VMs are going to be restarting. You need to have some of the essential Arch-specific devices like interrupt controllers and timers. And I'll talk a little bit more about what supporting protected VMs means. But in essence, there's memory isolation. You need to make sure that the VM is what you think it is, and that somebody else can say, yeah, what that VM did is the right VM that did that. So attesting that you were loaded by the right person. So a little bit about protected memory isolation. So there's a lot of memory that these VMs use that we don't want Android to be able to access. So this memory gets lent from the VM. And this diagram here is just trying to show, oh, you can't see the grid. Oh, yeah, you can. So just different scattered memories, regions get mapped into the guest memory and are no longer accessible to the host. And there's a mix and match of that memory. There's some memory that is shared with the host for things like VirtIO buffers. So some additions we had to do to AVF to support Gunya. So there's two primary components that live in user space and kernel. So the user space component is called CrossVM. That's the virtual machine manager. If you're familiar with QEMU, it's vaguely similar to QEMU. If you're familiar with KVM tool, I think is the other one that folks may be familiar with. So we need to add a new hypervisor crate for Gunya to use our Gunya driver that lives in Linux. In Linux, we've been trying to upstream all of our changes to kernel.org first. Those patches are still very much work in progress, but we're treating that as kind of our top priority. And this driver abstracts all the communication to Gunya. Yeah.
Yeah. Okay. Yeah, continuing with the changes we had to make, we had some enhancements in Gunya itself. We now support host-only device emulation, stolen time accounting for the VM. We also now execute PVM firmware before we actually run the protected VM for AVF. Along with that, to establish a chain of trust, we have changes in the bootloader being the root of trust. The bootloader loads the PVM firmware, verifies the firmware, and attaches a boot certificate chain to it. Gunya, when requested to run the protected VM, it first loads this PVM firmware with the BCC, and then the execution moves on to protected VM. In this Android 14 use case of isolated compilation, Microdroid basically compiles and signs the apexes and stores it in the storage. And on reboot, the whole flow repeats, and then microdroid uses the BCC to actually verify the Apex, compiled Apex, and then installs it on the device. Some more changes in regards to debugging the protected VM. Today, again, the bootloader helps load the debug policy, which is actually a DTB overlay. It overlays the DTB onto the host DTB and also informs the PVM firmware that the VM instance that's going to be launched next would be debuggable. So it enables ADB and console, helping debug the VM. What's coming up next? Like Elliot mentioned, we have our patches being upstreamed right now. Our V15 would concentrate on mostly memory management for the guest. We want to control the guest memory through an FD. Also, dynamically grow the VM based on demand. We are also trying to work on KDump to improve debugging and extend VM communication to the firmware. We have quite a few challenges we are trying to solve. One of them I would like to mention is how we want to sanitize devices when the VM is no longer runnable. Today, PKVM uses EL2 modules. The device drivers are inserted into the PKVM, where PKVM takes over once the VM crashes to clean up the devices before it is handed over to the host. But Ganya doesn't want to follow this model. Instead, we are heading towards having a more privileged, secure VM, which would run after the VM, clean up the devices on behalf before it returns to the host. Yeah, these are the references for some of the topics we spoke about. And yeah, thanks for the opportunity to explain our experience here.
Making us into football stars. So you said that you boot into another secure virtual machine to clean up the device status before you give it back to the host. Why that approach versus, I guess, PKVM does something else?
Yeah, they are using
what's the reason
EL2 modules. Yeah, PKVM is planning to use EL2 modules. Yeah, Ganya doesn't want to have any device driver in them.
Any module support in the
Yeah.
okay, hypervisor.
Yeah, we wanted to keep it as thin as possible. So.
Well, one of the mysteries I had about PKVM that I couldn't figure out is how it protects the guests from the host. And eventually it was explained to me that eventually what happens is the actual PKVM will sort of panic if the host try to access the guest. How does Gunya treat that?
Yeah, go ahead.
Yeah, I mean, it's basically the same thing. So PKVM and Gunya both just unmap that memory from the host memory, and so they are the same.
So the question is, what happens if the host were to try to?
Oh, so you get a stage 2 fault, and if depending on what kind of access it was, the kernel could panic. If it's kernel trying to access the memory, if it's user space, it's I think SIG bus.
Yeah.
So yeah, so a lot of the upstreaming work, just so you know, is trying to figure out what's the right way to make sure that the kernel can't panic on that. So yeah.
Are there any limitations in PKVM that necessitate building this on top of Genya for Qualcomm?
Yeah.
So the question was, why did we build Gunya on top of PKVM?
Why build AVI support on top of Genya as opposed to
Just switching to PKVM. Great. Yeah. So I guess from our perspective, we want to try and support one hypervisor and not more than one. So we've been doing Gunya for 4 years, which is longer than PKVM has existed. We have a few different other use cases that we want to try and support that AVF doesn't want to really care about, which I think is fine.
Yeah, we actually already support QCVMs, or we have been supporting for the past 4 years. So AVF was just an addition for us. So we wanted to continue with Ganya. Auto was, one of.
Oh, what do you have?
On Auto?
Yeah.
Yeah, I mean, Auto is one of the use cases that Ganya is running on today. and we do not have the Linux trust chain there. So we do need Ganya.
Yeah, you mentioned the EL2 scheduling. I'm curious to find out more about that and the complexity of having the scheduling code at EL2.
Yeah, I think it's a simple time slice scheduling that happens. These are mostly for critical VMs, which need to exist and run irrespective of how the host is, how much pressure the host is handling. So yeah, we have some use cases we are running today, which schedules in EL2. Yeah, but it's just a simple time sliced scheduler.
My question was quite similar. I mean, with PKVM, they use the kernel scheduler to schedule everything. And for you, because you're completely out of the kernel, which kind of scheduling and how do you handle all this task placement, frequency scaling, which is quite, I mean, complex.
AVF VMs are using what we call proxy scheduling, which is what you guys are used to with PKVM, where where Linux will donate vCPU cycles to another VM. And so for us, we call that proxy scheduling because you're donating the rest of your slice, your time slice, to the other VM. But yeah, so does that answer your question? So I guess the answer is the problems you guys are facing are the same things we're going to be facing for AVF VMs. So we're interested in figuring out how you guys want to, collaborating on solving those problems.
I'm kind of confused. Wouldn't you still need proper scaling inside the VM, whether it's Ganya or PKVM? That's like, I don't understand how you're saying you wouldn't run into the problems. And then the other part of the question is just for my understanding. We're saying in Ganya, a VM can forcefully steal CPU from the host?
Ganya would schedule the VM. Yeah.
Yeah, but
Yeah.
like without the host giving up, you're
Yeah.
like, okay.
Right. Yeah.
So yeah, those two questions. I guess the first question, why you would have the same problems. Why do you say you wouldn't?
Yeah, we would have the same problem, is what he said. Yeah.
Okay.
Yeah. Yeah, I think we are almost done.
No. I have a question. Do you want to speak AVM?
Thank you.
So, just so you know, it's the arrows there.
Okay. Okay. Or just that you push it this one.
You have to click on.
Okay. Hello, everyone. I'm Neil Yan. I work for the Nilaro. So in this session, I will to introduce our work for porting the Android Automotive on Zen virtual machine. So first, I give you some of the background introduction. So in Nilaro, we have the Automotive project from last year until this year. So the goal for this project, we want to locate the gaps when we run the Android Automotive OS on Zen virtual machine. So here we can see that there we need to set up for both the host and the guest, the environment. For the host, that you can see that because there have many the components for Zen hypervisor, and there have Zen the toolkit. And we also need to integrate the QEMU, and we also need to enable the Linux kernel, this kind of thing. There also have many dependency. So this is why in Nilaro we need to build the Yocto-based distro. So we now often use the TRS is trusted stack, reference stack. So it can allow us to do debugging in a single place for the host, host side. For the guest here, we use the Android, the AOSP, the master branch. But here I have one thing that what the target we want to use. Because that, as we know that the Android cuttlefish, they have the build target. Here is the AOSP CF ARM64 auto. So this want to build Android image, run the automotive, the software on the cuttlefish virtual machine. But cuttlefish is the KVM-based virtual machine. So based on that idea is that when we want to run the Android Automotive OS on the Zen, we want to try to reuse the component as possible with the existing work. So this is why we selected this target. So just now, just want to mention that this target, the name has been renamed to the new rename recently. So we're not in the bottom of the page. Okay, so based on that, now the work, we are not the first one to work on this field. So EPAM, the Conics, they work on this field for a very long time. So we just based on their work to enable this environment. So we test on 3 different hardware platforms. The first one is the EVA platform. So EVA platform is very powerful. So it is used Ampere SoC. So they have 32 Novaverse M1 CPUs. So this is why that is the main platform we are working on. There have another platform is Tiny Chips Dolphin 5. So this platform is very interesting that it have a GPU partition. So this is why we select, but I want to clarify, we don't enable the hardware GPU at the current stage. We just use the software rendering. But there is a potential the platform we can do the GPU, the related enabling. The third one is RockPi. Because that is open source, the community, the platform. So all the soft component has been open sourced. So this is completed by my colleague Jun. Okay. Okay, so this just give quick sense that how what's the system put up. You can see that at the background there have the TRS or the host system run in the Zen DOM 0. So in the front end you can see that in the front end you can see that they have the is a window. So this window that run for the Android Automotive OS in the DOM U. So current status we can see now we try to do some upstreaming work in this part. So for the Android U-boot, they have maintained the repository. So we have upstreamed the patches for the U-boot. The patches has been merged. The kernel patch is just simple, just one patch. So it patch to enable the Zen fundamental the features, for example, to enable the Zen for the message communicate or for the event handling. But this patch has not been merged because that Zen, the Android common kernel don't want to maintain the Zen the feature. So now the plan is don't upstream this patch, but we have agreement that we can upstream the changes for the Android cuttlefish. So we can allow the cuttlefish to support the Zen virtual machine as possible. So we can see that for the display, the model set at the DRM, the patch has been merged. There have another thing that we tried to use the virtual I/O virtual device as possible, but there have one exception is that the Zen virtual block device. So there have one patch need to enable the support the Zen virtual block device in the cuttlefish to boot up the virtual block device. There also have one regression. We found that now Android cuttlefish they don't support don't support. They don't use the HVC0, this virtual console to add the interactive console. So we need to apply one patch to enable the virtual console to be used in that. Okay, this is just for the guest side. So you can see that because the Android cuttlefish support the virtualization, Google have did the much work at here. So we just to try to use. So you can see that for the Android this part, we don't need to apply many patches. We just to apply less than 10 patches can enable the Android Automotive on Zen. But on the host side, we can see we need to maintain several parts. The first part is that we need to maintain Zen and QEMU repository. So basically, there have a significant work done by EPAM. So we need to support the virtual IO PCI, the virtual bus. So this is why we need to maintain these two specific repository to enable the virtual IO, the virtual PCI bus on the Zen for the Zen virtual machine. There have some no issue. As we know that cuttlefish that when they enable some of the virtual device, for example, Wi-Fi or the secure environment, they don't use the virtual IO this framework. They just to use the hypervisor virtual console to do the communication with the host side. So on the host side, they have some program to do the communication. This part we don't port from KVM or cuttlefish to the Zen. So in this case, that you can see that no issue. This no issue. We just to disable some of the service, for example, for security the service. So this is why we disable the file system encryption and OEM lock this kind of service. So there have some link give the demo for the steps for enable the Zen run the Android Automotive OS on Zen virtual machine. Okay, so here have some like the next step or what we want to do. So first thing that actually now we have some pinpoint. The first thing that we need to maintain these offline patches by ourselves. So you can see that almost every 1 or 2 months when we rebase to the latest AOSP code base, then we can see there have some breaking issue. We need to apply new patch. So this is why I want to upstream these patches as possible. There I have another thing we can see that when we want to reuse the cuttlefish AOSP image run on the Zen virtual machine, when cuttlefish launch, it will to dynamically to generate the Android image, and it also need to dynamically to append, for example, the boot config file into RAM disk image. So now we do this kind of thing use some like 2 steps. So first one, we run the cuttlefish. The cuttlefish run the cross RAM to generate this Android image. Then we copy this image to Zen host machine, then to launch the run Zen virtual machine. So this is something that is a manual thing we need to do. So it's still a bit like the no efficiency for us. So next, there have another thing what we can do is that now we there have some development based on the vhost based backend. So we want to develop some backend program is standalone background program. So this background program that not in the QEMU is just the standalone. So you can see that now we have developed some virtual device for ING, X2C, GPIO. We also have some in progress the backend the device. We also there have some colleagues now work on the Vulkan support for VoltIO GPU. This is in progress. Okay, so this just the current status. Okay, so do you have any question?
So maybe just in the beginning when you were talking, so could you just clarify what's the benefit of sort of having Automotive and Zen? Is it just for, it's probably not just for concept, so what's the actual end goal here that's we're trying to achieve?
Okay, so Masood, do you want to give some information?
I just want to make sure that I got it right.
For sure. So the question is, what's the end goal or the benefit of having Android sort of Automotive running on Zen? What are we trying to achieve?
So we were doing a proof of concept to support automotive, mixed criticality and virtualization all in one cluster. So the idea of working with a type 1 hypervisor, we know that Xen is not going to get into a car. You need a real-time hypervisor, but it's still a type 1 hypervisor. And so that was the first phase of a program like that. The second phase was to integrate that with VirtIO daemons that we started taking out of the VMM. So those VirtIO daemons could be basically running on any kind of POSIX environment so that you stop reinventing the wheel every time that you want to swap your hypervisor out. And basically get VirtIO to be accepted by the community that builds real-time hypervisors so that you can have a direct swap from type 1 hypervisor that you prototype on and the ones that you're paying dearly for per seat. So that's the genesis of the project.
Oh. All right, thank you, Leo.
Okay, thank you.
So who were,
I'll just leave that there. Maybe we want to wait because some people like turn on online at the schedule. I mean, if you start a few seconds before, it's fine. Just
Everyone, my name is William McVicker, and Peter Griffin and I will be talking about Pixel 6 support on Android Mainline. So Pixel 6 has been supported on Android Mainline for 2 years now. And the goal of the project was to increase testing for GKI with a real Android in-market device. This allows us to catch regressions from upstream merges that come into Android Mainline before they are propagated to Android vendors. It also increases Android-specific testing on real hardware that is used in the market. And since kernel version 5.10 and later, we've been using Pixel 6 for testing. So every GKI kernel change that is being made is being tested on Pixel 6 in pre-submit and in post-submit. This also includes all the LTS merges that come in from upstream into the 5.10, 5.15, 6.1, and Android Mainline branches. Those are all being tested on Pixel 6. This project also allows for kernel developers who are testing upstream patches from the list to evaluate performance impacts, and it allows them to contribute to the discussion upstream. In addition to all the testing that we've added, we're also starting to lay the frameworks for in-market kernel upgrades. We found that it's easier to maintain functionality and the performance incrementally for each kernel release than to upgrade from one LTS release to the next. This means that when you're bringing up your device, you can focus more on the changes on that specific kernel release instead of focusing on upgrading your drivers from an older LTS version to the LTS version that you want to upgrade to. So I dug up a list of changes that have either landed upstream or are currently being reviewed on the list that directly use Pixel 6 with Android Mainline to develop and test. So you may be familiar with these. Pixel has been doing some 16K support. There's VM CPU Freak, proxy execution, a lot of PKVM development. User fault demove operation, binder development, in particular the new Rust implementation for binder, multi-gen LRU. All these have leveraged the work that we have been doing to support Pixel 6 on Android. One of the reasons you may pick Pixel 6 over the available AOSP development boards out there is that they lack certain hardware features that you find on real phones. In particular, you can test on an in-market device that has a phone form factor. This means you can do thermal testing, performance testing of workloads that real users will be seeing in the field. And we've been incrementally adding documentation that for this project. So you can now find at this first link the steps to build the Pixel kernel with the latest Android mainline, as well as the second link is the link to download the source code. So now I'm going to hand this off to Peter, and he's going to talk a little bit more.
My name's Pete Griffin. I'm the Google Landing Team Tech Lead at Linaro, working with William and Google on this project. So the chart on the right there, it shows the lag between when a Linux release is made by Linus Torvalds, and then the blue bars are how long it takes that to get merged into Android Mainline. So you can see, like, typically it's like a day or a couple of days, and that means at that point that's running on Pixel 6 and all the drivers have been updated. So we've there's at least 16 upstream bugs that we've detected by running CTS, VTS, and all the testing that Betty talked about in her talk on real phone hardware. But if you look at RC3, which is the red bar, you can see that there's a much bigger lag. So, essentially we don't always have this testing. We lose a lot of the RC window because we have to fix up the Pixel drivers and some of the other ACK stuff, technical debt. So if these drivers were baked into the kernel and they're already upstream, we'd be able to do a lot of this testing a little bit earlier and hopefully get the detect and fix regressions earlier in the RC process. So why upstream Pixel 6? Like William's talked, there's a lot of benefits with updating the downstream drivers with every kernel release, and William's kind of talked about that already. But if we upstream the SoC and the phone to Linux, then obviously all those drivers are baked into the kernel. So we don't have to have this lag when a new kernel release comes out. We don't have to go and fix up all the drivers. We can start the testing earlier by integrating the platform into services like LKFT and kernel CI. We also have a phone form factor upstream kernel development platform, which is quite cool. So you'll be able to just take the Linux release and compile it and run it on your phone. And there's some technical debt in GKI that can't be upstream currently because it hasn't got a user in tree. And if this phone, if the SoC on the phone is upstreamed, then we will have a user and it will allow us to reduce some of that technical debt as well. So this work started. The initial patch series is on V3 on the mailing list, and we have sort of initial SoC and board support. So it's got clocks, UART, watchdog, enough support to get to like a BusyBox shell, basically. So yeah, depending on what you want to do, at the moment you could go and get like 6.6 version of the drivers publicly from AOSP with Android Mainline and run it and have a full featured phone, or you can take like when these patches get merged, you'd be able to take just upstream kernel release, compile it. Obviously, have much more limited support at the moment, but that will improve over time. And the goal is, as we upstream these drivers, we'll retire the sort of downstream forked versions in Android Mainline, and slowly more and more of the platform will be upstreamed. So, yeah, this is the kind of technical discussion topic we wanted to get everyone's feedback on in the room. So typically, the Android phones have quite a few different, like for a particular phone, there's a bunch of different variants before it reaches mass production. And ideally, we want to be able to boot all these using the upstream kernel. The patches we've sent so far, we've just put like one DTB board file for the mass production phone. But typically there's, I think we counted up here, just over the 6 series of 6 Pro and 6A, there's like 29 different board variants. And we don't really want to have to add like a DTB for every single one of those in the kernel. So the downstream solution that's being used at the moment is to have like a common DTB, and then it uses an overlay to the bootloader applies that overlay depending on the specific board variant that it is, and that allows us to have like one DT image that has a couple of base DTBs and then like the 29 different overlays, say, and we can package all that up together. So we'd like to have an upstream solution for this problem, essentially, and I don't think one exists today. As I understand it, with overlays currently, like upstream expect the board overlay to be like a physical daughter board. So I'm interested to get people's opinions on, you know, if we can do away with that concept and have an overlay as like a, you know, a board. Oh, do we have the mic for Sarah?
Yeah, so I am CC'd on it, but I haven't followed the email thread fully. Is the main contention is adding a property called board ID? Is that what, right? Because you're not doing anything in the kernel itself with these, right? Just that the bootloader is going to look at this board ID thing to figure out which overlay to apply.
Yeah, so I mean, downstream uses a board ID, and I know like there's some upstream Qualcomm platforms that use a board ID and a MSM ID, but the key feature is we want to be able to apply overlays to a common board DTB.
But you want to enable the bootloader to apply the overlay, even for an upstream kernel. That's what you're trying to do, right?
Sorry, say that again?
You're trying to enable the bootloader to apply the overlay.
Yes.
And to enable it, you need to have this board ID property.
Yes.
And that's the part you're trying to get. Okay.
So yeah, I'm looking to get the room's feedback on overlays to support
You have a
different
question
board
in the
variants.
chat. If you check the chat on the left-hand side, there's a question for you.
Well,
Is there not?
can you show me?
Can you just read it?
Yeah, maybe somebody.
Yeah. Sumit, do you want to read it up?
So Trilok says overlays we do are the DTB plus DTBO and DTBO plus DTBO at compile time in QC. DTBO plus DTBO is not supported upstream through DTC. So QC uses the board ID plus MSM ID, and overlays gets complex. So compile time is better due to boot time constraints. I would not prefer the boot time resolutions. That's from Trilok at Qualcomm.
Okay, so
I don't think there's a question. I don't think there's a question. I think his view around your question of what would you prefer, his answer is that he would not prefer boot time resolution of DT overlays. He would rather do a build time, compile time. Yeah.
Okay, I can see the.
I know what we do because I wrote it.
Don't use the thing you're using.
No, we do a build time check to make sure that the overlay actually applies to the DTB. I think you probably developed similar patches. I just want to say I would really like whatever solution we come up with, I'd really like it if we didn't put the metadata outside the DTBO. It's really hard to track that metadata if it's living outside the DTBO itself. You have to drag it around a bunch of images and figure out what you want to do with it. I think it just gets complicated. No question, just a comment.
So we do compile time application of the overlay to the DTB, but whenever we boot up, we allow the bootloader to select which overlay to use based on what hardware you're running. So the bootloader will read a register or a fuse that has this board ID and board revision in it, and then it will look up in the table to say, okay, we're booting up with this specific hardware, pick this overlay, apply it to the SoC-based DTB, and then continue with that device tree blob. I think Qualcomm does that too, right? Who else has a question?
What are the concerns you have between, say, shipping a bunch of overlays that get chosen at boot time versus shipping several like complete device trees that get chosen between at boot time?
So as you can see here on the slide, if we did this just for Pixel 6, 6 Pro, and 6a, which all use the same SoC, they have slight variations between them. If you wanted to ship a single DTB image for each one of these 3 devices, then you will be using an additional 6.8 megabytes. And the DTB right now is concatenated at the end of the boot kernel, the kernel image. And so by having a single base DTB for each of these devices, and then a separate overlay for each one to adjust the base DTB, you can save 6.8 megabytes. And if you extrapolate this to Pixel 7, 7 Pro, 7a, Pixel Fold, Pixel Tablet, it starts like accumulating, and obviously the memory will start accumulating as well. And so we want to, as for a scalability point of view, be able to ship one device tree blob to all millions of devices out there, and not have to have 12 different, and I think of Pixel 8 as well, 12 different images for all these different devices.
Okay, we've only got 1 minute. Oh, there's a question.
I agree that the overlay stuff sounds great. I'm a little curious if the 6.8 megs is compressed or uncompressed, because at least on Chrome OS, we do ship probably far too many different revs of boards. It's very handy, and they do take up a lot of space, but they do at least get compressed, I think, with like whatever, one of the really good compression algorithms, and it becomes a lot less of an issue.
Okay, so you ship a full DTB for every revision,
right?
But you
I mean, it doesn't take up a lot of space in the source code because it's all a bunch of DTSIs and a bunch of include files. But yeah, they all get compiled, and we ship a whole pile of different versions, and it takes up some space, and you compress it, and it's not terrible. But yes, overlays would be better.
Yeah, and Christoph, you have any thoughts on overlays for supporting board
We're
variants?
going to have to switch over to the next speaker. I'm sorry.
I'll take silence a minute, it's fine.
Okay, thank you. Yep. Hello, everyone. My name is Qais Youssef. I work on the Pixel kernel team for performance and power. And today I will try to walk with you about the challenges that makes running mainline kernel not possible. And you see all these vendor hooks that people don't tend to like them, but they are one of the unnecessary evils that I hope we can minimize. And that's the discussion I would like to do, to basically get into, like how can we actually keep them as small as possible. But as you can see, the real world problems are quite a lot of them, and they are tricky. So I'll just give a quick overview. So like vendor hooks, for people who don't know, like they are just simple trace points. They are strategically placed in the generic kernel image, like in Android, so that vendors can either completely override the function or extend it somehow to fix a problem they have, whatever that problem might be. And if you ever try to remove these hooks, actually, you will run into issues. And like it's mostly related to quality, really, not about I mean, there can be some stability issue. We'll come into that like in a bit, but like it's a lot of them are about quality issues that you will get. I mean, these are some subjective ideas or like problems that you can run into, like related to UI, battery life, thermal, and you might lose access to some hardware potentially. Like you never know, like what kind of extra features and like hardware proprietary being in the SoC. But it's mostly a quality issue, really, that we're trying to address over here. But like, if you are buying a device that's really like a few hundreds, like not a few hundreds, like almost 1,000, you really care about that part, and you don't want to sacrifice it at all. One of the major issues, actually, that and that I work quite a lot, so I have a bias towards it, is the scheduler. It's tend to be changed quite a lot, and it's a very difficult problem. Like, how do you fix the scheduler for everyone? With the generic kernel image, like we just have one thing that's shipped for everyone, and well, you want that to work for everyone as well. But people like run into all these UI-related issues, and like, if I wanna summarize the problem that actually limited, people like want to change it. There are a lot of features that are missing. They are not available. We hit a lot of bugs that needs to be fixed. And there is the tunability part of things, which is maybe a very kind of time-bombed, or like the tunability word, people like tend not to like it, but I'm not talking about scheduler tunability over here in a sense, like we don't want the debug FS to tune the behavior. But the system as a whole, like, has some kind of like characteristics that you want to be able to control to get a trade-off for like performance or power, for instance. Beside the scheduler, like we live, like the Android is a very brutal world where like we have an SoC, several SoCs like being produced every year that it's almost impossible to catch up, especially for drivers and other stuff. Erratas is one of the issues that come quite a lot. Like, how do you handle them? Like in a generic kernel image context, it might not be suitable for everyone, or like the solution might not be mature enough to include it, or like it might be temporary. Like, I don't know, like there can be lots of issues over there that require it. And with the big little like architecture specifically, and the way the DVFS work, like in Android world, like you from user perspective, like application developer perspective, it's really very hard to program for them. So like this kind of created a lot of divergence like in the user space, and like each vendor like tried to end up with some kind of SDK to provide these kind of interfaces and hide all these problems from the user, like, hey, do this, do that. And we really lack a community in this regard. Like, how do we do it? And like we kind of need somehow, like I will come to this as well later, like kind of ownership. Like this should be our problem. It's not directly a kernel problem, but it is really a problem that forces these kind of vendor hooks to be implemented at the end of the day, which connect to SDKs, which, you know, all these kind of inconsistency and fragmentation problems that we run into. So like what kind of like issues we see? So like from the scheduler perspective, like fair scheduler is really important. Otherwise, you will not get a functioning system. But it's not really like a lot of people spend a lot of time fighting the fairness of the scheduler, because not all tasks in the system are equal. Like especially in a very interactive workload where like for instance, like the most basic example is UI. Like you're interactive. When you scroll, suddenly certain tasks really need to get a priority over other. But how do you do this dynamically in a very consistent way? And most importantly, really portable. So like you write the software and it just works for all hardware, for all topologies. As you know, like ARM topologies, like really for the Android is really like very, very diverse. You can have 6 littles, 1 mid, 1 big. You can have too many things, and like fairness becomes an issue generally when people have to handle this kind of workloads, and this basically creeps up into some vendor hooks to basically break this fairness in certain use cases and certain scenarios, so that basically the right thing happens for the end user and they are happy. It's ugly, but it's happy. Latency interface is actually one of the things that has been growing for years that we actually really want. And it's very important, like one part of the unfairness, like we want, like when there is a latency-sensitive task, fairness is not important over here. Latency is more important. I'm trying to identify more items that actually like needed, but one of the issues as well, like with AES, like it's like it has a packing behavior, which is the opposite of the default scheduler behavior, which separates tasks. And like you want to break them around, like how do you handle this in different situations? So there is a prefer idle implementation in Android as well, which is good, but like it's very power hungry. So like it's creating problems, and this also leads to other problems, which vendor hooks fixed in vendor hooks. So you get kind of like this kind of feedback cycle into issues. There is a general like lack of mechanism. I think we had in the scheduler people who attend the scheduler real-time conference for like a quality of service kind of framework, like because not all tasks are equal, like there is no way to basically like, we don't have any framework to help build like libraries and other things to say these tasks or these kind of things have this kind of properties, please do it for me transparently, like, and it will just work. So we don't have, and like the example I gave with like packing, spreading, like latency, I'm sure there are more that needs to be unpacked, but that's actually type of the difficult task. Like how do you unpack and analyze all these workloads to come up to these conclusions and distill them to few quality of service that the Linux kernel should understand. We do see a lot of inversions and starvations problems. Like, I mean, they're rare maybe like, but still not rare enough like to not affect the quality at the end of the day where like you end up with very bad use cases. CPU shares at some points like it becomes difficult to use generally, and like you might actually become say like it's unusable at all at some point at certain circumstances. Like it depends how you view the problem. Proxy execution has been growing for years. It's hopefully the ultimate solution. Like I am personally like keen into like staging the problem into like something that makes it less worse to something that makes it even less worse and moving on. But like it's quite a problem. And we, with DVFS, the way DVFS works in Android, and it should be in Linux, but like Intel do things differently, but like an ARM system, and the big little, you really see a new class of inversion, performance inversion. If you have a task that's running at a very low frequency or in a little core, and it's holding a lock or like doing some important work that somebody waiting for it, it will hook up some latency sensitive tasks. And how do you deal with that? These issues. So like you really need to boost it, not just in priority. It needs to run on a bigger core or like somewhere at a higher frequency. And there was no concept before that, like about these kind of issues. One of the issues that creep up a lot is that background tasks like end up stealing a lot of perf and power. Go ahead. Do you have a question?
You have one point about locking and a priority inheritance. There was another talk before about the binder. The binder is heavily used, and it seems that the binder is heavily doing some lock. So have you checked or studied how much of this locking inheritance can be just fixed by removing them completely from the user space? I mean, you can't really remove all this locking inheritance, but maybe in some place you are using too much lock, and you should move to some lockless behavior just to prevent this kind of inheritance.
Yeah, but the problems, like there was one, I think in OSPM we discussed that, where Unity, like they were saying in one of their games, they had issues. Like you cannot go and fix that. Like applications that
clearly you will not fix all the things, but I mean, if it's a real problem, a major problem for you, and from the figure that have been shown, you can decrease by, I think it was 200. It was from 200% less. So maybe that could fix and make your priority inheritance simpler than what you need right now to fix that. Instead of trying to have a smarter priority inheritance, you need to fix this inheritance. But on the other side, maybe you also need to fix what's going on in user space to prevent such kind of circular or deep inheritance things.
Yeah, I agree. But like, I think the lesson that has been, it's really hard. And as I said, like, even if it is very few use cases that happens, it still like will impact the overall quality, and people will perceive it. So if there is something similar to be done, I'm really happy to do it. Like for me, my goal is like, if we can have something in the Android 15 timeframe, that would be amazing. But yeah, very ambitious. Okay, so moving on. So like background task can steal a lot of performance and power, and people like really like, this is kind of like tricky to describe how this is being done. It's like you want to move some task away, which has implications with the load balancer, and we have some issues with current like as well, like mechanism. RT is quite tricky as well, because you want energy awareness with RT. It by default it runs at max. With UCLAM-min, we like max frequency. With UCLAM-min, we fix that, but task placement is a big problem, because you don't want to end up with a big core quite often. And if we have ever latency, like RT is latency sensitive, there is no interclass like operations. Bug fixes takes a lot of time, and even if you like want to go upstream, you're forced to do it in vendor hook. So I'll have to skip a little bit just to go, because we're a bit short in time. So how can we break the deadlock? So I think the basic message I want to deliver over here is like that we need to have some kind of paradigm shift in times like when we define something is going bad, and start like giving the user space some kind of like like they need to get their brownie points for like, hey, I'm having a good perf per watt. It's not just a hardware and like an OS problem where like, hey, you just look what I do, I'll fix it automatically for you. Although, like, if you really want to productize, you have no option. But we really need to start thinking more like how can we start helping applications write better programs that end up being portable and work everywhere. And that's really what's going to get rid of like a lot of these vendor hooks that's really required to make sure that things just work for these workloads. Because at the end of the day, it's not acceptable for a commercial product to have something that just basically have these small lapses, even if they are rare or small. So they are required, but as you can see, the complexity of these problems is quite high.
Hey, I'm just kind of confused by the last bullet. Isn't that kind of opposite of what you're asking? We don't have any special libraries like this for the Linux like desktop, do we?
Yeah, but that's missing over there. That's not mean it's better over there. I don't think Linux programming generally is very easy.
Yeah.
So like people want to write program for Linux, I think they struggle. Like at
Then
least in my
wouldn't that
experience.
mean if you're trying to give user space more control and more libraries, then we'll have to do that for the desktop too?
I don't think it's a different problem. So I mean, you can choose what you want to do, but like from my experience, like people coming from Mac OS, like Apple, like for instance, or like even on Windows, they find a lot of flexibility of being able to do things and like tell them, and they come in Linux and sometimes I speak with them, it's like, hey, why is not the same like this? Like, yeah. Like for instance, like Apple have a very nice, like something called the Grand Central Dispatcher to make multi-threaded programming a lot easier in Linux, on Big Little and all these kind of stuff. I mean, these kind of things will help quite a lot. How they connect to the OS and this kind of things is a different issue.
And then I agree with your point in general. We should, if there's need to give user space more control, yeah. But at the same time, where do you draw the line too? Right? For example, in terms of the Big Little DVFS inversion, Matthew then I think was talking about packing tasks in a different way. I would think that might help in this situation where you bring the tasks into big, tiny tasks instead of running it on little. So then if that ends up helping, then you don't need to manage it from user space. So how do you know?
Yeah, in my opinion, like it's a continuous effort.
Yes. I didn't see him at all. Come on.
Hi everyone, my name is Kalish and this is Juan. Today we'll be talking about 16K page size supports in Android.
Okay. So basically it's like why 16K page sizes, right? Right now, most of the mobile devices, they have ARM, and basically ARM supports 4K, 16K, and 64K page sizes, right? So basically, it's like what we decided is like we decided to try to boot Pixel 6 with 16K page sizes. And basically, it's like what we find out is like we saw like 4 times less page faults, and also it's like the app launch times decreased by in average by 3%, and in some cases, like for example, Google search it decreased by 16%, right? And also the same with Google search. Sorry, with Google News, it decreased by 30%. Also, another thing that we saw is like there is less power consumption with 16K page sizes, right? We find also some trade-offs, like for example, with 16K page sizes, we consume a little bit more memory because right now the L segments are 16K instead of 4K, and also the disk space increase with 16K page sizes.
Just a bit of background. We'll go over a simple ELF file and how we load it into memory, just to get everyone on the same page. So here's an example of an ELF file with 3 load segments in some nice round numbers for just to simplify the explanation. So the virtual addresses specify how we load the load segments relative to each other, and the alignments is important because we can only enforce the protection bits on a page granularity. So, and how the loading happens is first the loader, at least in Android, the Bionic loader reserves the entire memory region, which extends the entire range of all the load segments. And then we map in each segment based on the vAddr. Here we are just using a load bias of 0 for simplicity. And there can be some padding in between the segments. This is just for the alignment requirements. However, with 16K page size, we need to increase the alignment to at least be 16K, at least page size. Else there are permission overlaps on the same page, and we cannot enforce that. So the same thing happens again. We reserve the memory region for all the segments, then we map in each segment. And we have the padding for the alignment requirement now 16K. So there is a bit more fragmentation, and since the pages are larger, and a bit more VA space usage. However, historically, Android has always aligned ELF files to only 4K alignment. So we cannot simply change the page size. So we need to first migrate the ecosystem to have a larger ELF alignment. Then that will allow us to change the page size. So this leaves us with a situation where we have 4K page size system with a larger ELF alignment, 16K. And this is an issue because it introduces another problem. When we map in each segment, the segments are only rounded up by the page size. So what happens is the original reserved mapping is split, the VMA is split, and we have an extra proton mapping between each segment. So this leads to a slab memory increase. In Pixel 8, we found about 25 to 30 megabytes increase after boot. Yeah, there are multiple ways we could fix this problem, maybe even in the static linker, but we 2 approaches we explore in the Bionic loader we can do at dynamically at load time. One is we could unmap these extra VMAs, which leads to some additional system calls and some overhead and additional complexity in the loader. But another approach, perhaps simpler, is to extend each VMA to the end of each load segment VMA to the beginning of the next load segment VMAs. So this is conceptually not that different from the gap that already exists from the end of the segment end to the 4K, next 4K boundary. Instead, it's just to the next 16K boundary.
Yeah, so basically it's like with 16K page sizes, if we want to run a 4K app, it won't run, right? So we try to find several solutions. And the first solution that we explore is like, basically it's like, instead of having every segment to have its own permissions, like for example, read only, read write, and read execute, what we did is like we memory map basically a region, and then we mark all that region as a read write executable. And basically, it's like that works. We were able to run 4K apps in 16K page size kernel, but there is security implications with this approach. The next solution that we try is like, basically we try to do binary analysis to convert one 4K share library to a 16K share library. And in order to understand what it changed, it's like we have to write like basically a parser that compare stroke by stroke of the different L sections. And then it's like we found that basically the global offset table, the PLT section changed, like the dynamic section changed. And yeah, and basically it's like we were not successful with this approach. Let's see, next one. Oh yeah. So the next thing is like we're going to talk about the driver issues. So basically it's like one of the, in Pixel we are using, Pixel 6 we are using a UFS controller. And this, when we try to boot Pixel 6 with 16K page sizes, what we found is like we found an error like, oh, the partitions are not found. So after digging further, like we realized that the UFS controller didn't implement the host controller interface, the standard. So basically, like this host controller interface standard says that you have to use segments larger or equals to the page size. But for this UFS controller, basically it requires to use segments smaller than the page size. So basically Bar provides some patches to fix that. But it's like we have some problems upstreaming them because it's like the patches fix a hacky. Basically a hardware that didn't implement a standard. Yeah, also another issue that we have is that with the trusty driver. So here is the thing, in the ARM architecture, you have several exception levels. And starting from EL1, EL2, and EL3, every level can have different page table granule. So here is the thing, is like when the kernel tries to talk with the firmware that is executing in EL3, it's like the kernel has one page size granule and the firmware has a different page size granule. And in order to talk, they share a buffer. So basically the issue that we found is like the kernel was saying, okay, the buffer is 16K page size, but the firmware is seeing like 4K page size. So basically it's like we need to provide a fix in the driver to basically to tell the firmware, hey, we're using a buffer of 16K page size. So, and the kernel see the same thing. Yeah.
So another issue we had to solve is how do we emulate a 16K page size on x86 architecture? So the first question you might have is, why do we want to do this? And the reason is for Android, most of the app developers are developing on Windows machines. The majority of them actually are, so they are x86 based. And running the ARM64 emulator for Android on x86 is extremely slow, so it's even impractical for some of these developers to do. So we need to provide a testing environment for the developers to be able to test and support 16K in their apps. The way we are going about this is we have a modified x86 kernel which presents to user space a 16K page size. However, under the hood, the kernel is still using 4K page size. And the way we do this is by like emulating the 16K behavior. So the VMAs are always ensured to be 16K aligned and the 16K multiple size, which and any syscall that operates on memory regions like mprotect or mmap and friends also have these requirements. So just one, I want to share one interesting situation that we need to handle for this emulation to work. So imagine you have a file which is less than the page size. In this case, in the illustration is 2 kilobytes, and you mmap it. So what you get is some page-sized multiple chunk of VA space. In this case, it's just 4K, one page. If you access anywhere on that file, it falls in the page. However, if you access anywhere after the 2 kilobyte, it also falls in the same page because this corresponds to the same page size offset in the file, 0. You can write on that extra region, but it doesn't persist to the file. So in the 16K, In the 16K emulated case, we need to, since the kernel emulates the 16K page size, we have, instead of just 4K memory area, we have 16K KB sized. So if we touch anywhere in the first 4 KB section, is the same behavior as 4K. However, if we touch anywhere after 4 kilobytes, what happens is the kernel will try to fault in another 4K page, which at some offset, which is off the end of the file. So it will give us a SIG bus. So the way we are handling this is we detect this situation and we replace that region with an anonymous mapping, so which gives us the similar behavior. And some user space programs like the loader try to zero these regions, which is why user space is touching it in the first place.
Do we want to open it for questions a bit, I guess, at some point?
Yeah, we can. Yeah.
Any questions up to now?
From Matthew Wilcox, who says this is a horrid solution.
All right.
Just a comment.
Okay. All right, so go on. If somebody's got a question, but go on. Yeah. Yep.
Is this solution like back compatible 4K? Like, let's say you ship Android with all these fixes, and somehow we decide to still keep 4K. Is it still back compatible to 4K?
Well, basically, it's like we are looking for a solution where we can have a 16K page size kernel that can run 4K apps. I mean, we have some solutions, but it's like probably they are not very optimal. So we are still exploring the best solution for this case. So we present, like, for example, one solution that align all the segments to read-write, that set the permissions to read-write executable, and with that we can run the apps. But it's like basically it's like it has security implications. Yeah. Another solution that we try to do binary analysis. Basically, it's like, yeah, we start parsing the L file, and then it's like try to fix all the offsets basically in the text section. But the problem is like some compilers embedded data inside the code. So basically, it's like we were fixing offsets in data that we shouldn't do. So basically, that's the problem that we face. And then we were trying to use linear disassembly and also recursive disassembly, but it's like yeah, with these two approaches, it's like we didn't succeed. Yeah.
Okay.
Oh yeah, so basically the last thing that we're going to talk is about basically it's like with 4K page sizes and pixel, it's like we have 39 bits virtual addresses, and then we have 3 level page walks. But with 16K page sizes, what we can do is like we can reduce the number of page walks to 2. So basically it's like this brings us a better performance on top of basically it's like we get 2% better performance on top of the 16K page size performance that we get. But this but basically it's like when we were trying to do like 26.
I'm sorry, there's a comment on the chat there.
Yeah, Matthew says, I think you're looking at the wrong solution. You should be looking for something that allows you to use 16 KB or larger page sizes, not looking for a 16 KB base size kernel. And then Trilok has a comment which says, emulation of the 4K will leave out performance benefits of the 16K on the table, but it's a trade-off. I thought they're aligning the binaries to 64 KB by default, so it covers all the variants.
Yeah, we're gonna have to take it offline because there are about 30 seconds left, unless there's last thing you want to say here.
No, thank you.
It's your turn. You get the last spot, so take as much time as you want. Hey, go. It's the floor is yours. John, do you want to moderate?
Well, I'm a tech lead at Linaro, and I'm going to be talking about AOSP and dev boards. So this is something we've been talking about for some time, just some updates here. We'll talk about dev boards. What are AOSP? What do we do with AOSP on dev boards? Why are dev boards in AOSP? And then some community building stuff. So why do we even need dev boards working with AOSP? I think the simple answer is that they provide a vehicle or a mechanism that allows us to have upstream, have an overlap between the upstream kernel development and the latest AOSP. So John and Amit have done a lot of, a couple of talks about it. There's an excellent talk that was given in 21. So probably I'd recommend that you go and have a look at that. But with these, this combination of upstream kernel and latest AOSP, we are able to find and fix regressions with upstream, implement and verify new AOSP features and technologies. For example, GKI development, the DMA buff heaps development, some generic HALs, etc. They were validated using the dev boards. What kind of dev boards do we currently support? So historically, we started with Hikey, which was the first 96 boards dev board. We went on to DBA410C, 820C, and the path. But right now, we are at the DB845C and the RB5, which are the current working devices. We are also working on enabling an Exynos 850-based dev board called E85096. So let's talk about AOSP on dev boards, basically what we do to ensure that the latest AOSP works on our supported dev boards. As AOSP develops new features, we as the dev board maintainers try to enable these features on these dev boards. So this helps with validating these features, but also reporting any regressions and issues that are found. So some of the examples in the past year that we have enabled with our dev boards are system DLCam support, where we have been able to, we created the system DLCam partition and also used the pre-built system DLCam image to validate this feature. EROFS enablement and validation. We also did module parallel loading enablement, which is right now it's a work in progress because we found a bug where the kernel crashes, and that's something we're debugging at the moment. There are a few features that we enabled at Linaro. So the software rendering target, we got inspired from Cuttlefish, where it helps to bring up AOSP on new devices where GPU support is not yet there. And right now it works on Qualcomm SOC-based dev boards. It needs some work to support other SOCs as well. Thermal HAL is something that is work in progress. It's a generic HAL that is developed by Daniel. I don't think he's in the room. Oh, Daniel is right here. So Daniel, and this is based on the upstream new thermal netlink using libthermal. Provides an abstraction to the platform thermal configuration, and he's validated it on RB3 with tuning. RB5 also shows no regressions here. We also ensure that AOSP keeps working on these dev boards. So we do a lot of testing around these with the AOSP user space and Android common kernels across these devices. Right now we test about, I think, 10 or 11 kernel versions and 5 user spaces and their combinations. Just as a sort of a metric, we have, since this January, we have run about 820 million tests and 2.8 billion since we started. We've caught and triaged or fixed 36 issues that are related to AOSP. Yeah, let's talk about how we keep these dev boards working with upstream projects and AOSP. So keeping up with upstream Linux, mostly we test with, we do regular testing on board, on our desk, as well as in our CI with the upstream Linux. And this helps us catch merge window regressions that happen due to changes upstream, like kconfig or sysfs changes, etc. So we've caught or reported about 18 issues since January this year. but also with other upstream projects that are relevant with AOSP. So Mesa, DRM, Hardware Composer, and MiniGBM, we found and reported or fixed a few issues. And then when those things get fixed upstream, we sync AOSP versions to upstream a few times a year. Also important to keep in sync with the Linux firmware upstream changes. So those are also things that we do. The topic of community developing with folks that are interested in AOSP, working with these dev boards, it's not new. We've discussed it a few times, but we did want to share some thoughts around it. So we would like to propose a collaborative community space for people that are interested in running AOSP on their dev boards. The overall idea is sort of simple. It's to provide one space where people can come and talk about and do discussions around how to bring up, how to have common HALs, what kind of best practices can we have around dev boards that work with AOSP, and any common scripting and tools. So we have, for example, there was a requirement last year where binaries could not be hosted on AOSP. And we had to create vendor packages, so scripts to create those vendor packages from the binaries, etc., that could be used like pixel-like in a pixel-like manner. Those kind of things are, some of those things are already available. This will help us consolidate everything about dev boards that work with AOSP. So essential info like documentation, code, but also binaries. We would like to inculcate AOSP-style collaboration for new dev boards and communities so that they are familiar with the idea of how to push patches towards AOSP using if they need to move over. This may help in case right now AOSP is not accepting any new dev boards, but if that changes in future, this can be a confidence boosting space where they know about how devices have functioned with various versions of AOSP and kernel changes, etc. In future, we would like to provide sort of a dashboard that allows for building, boot, and testing with mainline AOSP. So right now, this is the link that we have very recently created, dev boards for android.linaro.org. I know it's a mouthful, but we couldn't find a short name. So we have a discussion forum via #AOSP-developers on FTC. Right now, this website provides an AOSP style collaboration space. So there is source navigation, which is source dot the rest of it, Gerrit based review system. And we have moved a Hikey 960 based as a demo device to this system. It also provides space for binary releases like vendor packages.
Sumit, I have a question on that, if I may.
Yeah, of course.
So do you have any sort of requirements or commitment of maintainership for that? Because I think
that's part of my discussion questions, yes.
Okay, all right, because I think that's one of the issues that had been mentioned in one previous BOF at the Intermicro conference, for which Google was like, okay, well, somebody wants to add a board, but how do we know?
Yeah.
And in their mind, Linaro is a trusted source of continued maintainership, but other parties may not be, so.
Yes. So I think there are a few things that I would like to open up for questions. So I have, first question is, does this idea make sense? So should we do like a community space for dev boards that want to work with AOSP? And if there is we feel it is useful and relevant. Okay, I see Kevin says yes. So thanks, Kevin. We do want to make sure, same point as you, Kareem, that adding devices should be okay, but there should be somebody who takes ownership of them. So because it's going to be a community initiative, as Linaro, I don't think we want to take that ownership, but we want to have device maintainers. So we want to inculcate a community where if you have a dev board and you are interested in running AOSP, we all can come together. You are responsible for your dev board. So you make sure that whenever a new AOSP comes out, it works, it boots, it builds, all of that. And as we go further, we may be able to give or do a dashboard which shows how long something has been working well or not. So that's the other major concern that anyone, any such kind of an initiative will have, where people may just say, okay, hey, add my board, and then vanish. So that's something that we probably, as a community together, we need to figure out a mechanism.
Gotcha.
One thing that comes to mind naturally is that you have like a timeout-based setup where you say, if for 3 months nobody pushes any patches or does any maintenance, or the device is broken, you just check it out.
Yeah, for what it's worth, I think these dev boards are absolutely essential for doing any sort of work on Android. I know a lot of the people I work with, my company works with, are always asking someone a similar question. So, hey, which board should I use?
Yeah.
Right. And so this is a recurring question all the time. So I think this is a great initiative from my perspective, at least.
Thank you.
I agree. I'm pretty new to the Android community. My last position, we were basically working on creating a touchscreen based on a rock chip processor. And I find like many of the boards that we were looking at did not have ideal reference implementations. And so really having that community to help, how is the best way to port from the dev board to the latest? That is going to be huge, because so much of the documentation right now is very sparse, and unless you're a top tier manufacturer of device, it's very difficult to get started. So
So we can definitely try and keep that all collaborated in one space, and that's basically the idea.
Yeah, and so one of the things that, and no fault specifically at anybody at Google, but Google's not been very good at actually fostering a community around their sort of open side of things. And I think Linaro might have a bit more sort of a community around it to foster that itself.
Yeah. Oh, good catch.
There's a chance we might have RISC-V based dev boards coming out sometime in the next year. Any considerations on adding a RISC-V board to AOSP or this program?
Whether they would get into ASP, I'm not the best person to answer. I think somebody from Google may answer that. As a community initiative, I think if that is what the community requires and somebody steps up, I think we should be okay to get that added to this particular dev boards, even though Linaro doesn't work on RISC-V. So one last question I had was, any common code utilization ideas people may have where this kind of an initiative should help? So right now we have a couple of things we do use. We sort of reuse the audio HAL, ALSA HAL from Cuttlefish. We also reuse, there's one more. Yeah, the suspend locker service that we need for some CTS running. So device shouldn't suspend while CTS tests are going on. Any other thoughts around what can we use commonly? I'll leave you that. Leave you with the food for that. Yeah.
Yeah, I was just gonna comment that getting into Android platform development is something like knowing which of the HALs that were from Cuttlefish were Cuttlefish specific, or like the audio HAL that could be reused in a different platform that just supports ALSA.
Yeah.
That was information like that would be helpful.
Sure. Okay. All right. Thanks very much.
So thank you all for attending. This is a wrap for today. We have a BOF on Wednesday at 9:30 a.m. Is that right? Okay. So 9:30 a.m. Potomac something. Okay. Anyway, look it up. All right. For 9:30 to 11, I think, or thereabouts. And we have a couple of talks or things that we couldn't fit in the actual MC today that are slated for that slot. All right. So there's more content there in addition to actual open discussion. All right. Thank you all, and have a good evening.
All right. Hello, hello.